Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you.
Hi folks, welcome to WeAreDevelopers Live. Welcome to the DevOps Day. My name is Sead and I will help you navigate through the sessions that we have in the afternoon. Before we start, just a short reminder to check out the WeAreDevelopers World Congress 2021. It is the flagship event for developers from all around the world. We have an incredible speaker lineup, including the inventor of the World Wide Web, Sir Tim Berners-Lee, the co-founder of Stack Overflow, Jeff Atwood, the creator of Angular and AngularJS, Miško Hevery, and many other industry leaders. So you really don't want to miss this out. So check it out, wearedevelopers.com/world-congress. Also, if you're looking for a job or you want to explore the market, check out wearedevelopers.com and make sure to scan what's out there for tech talent in Europe. Maybe there is something interesting for you as well. And now let's talk about DevOps. It's a topic that becomes more and more important with every day. We all need to quickly deliver high quality and stable products, and that all with a very fast pace. So that was reason enough for us to dedicate a full day with multiple sessions just talking about DevOps topics. We will talk about continuous deployment, we'll talk about GitLab CI pipelines, infrastructure as a code with some nice examples as well. We will talk about containers and we will hear some cool stories surrounding Kafka. Grab the opportunity to ask your questions to the speakers using the Q&A tool on wearedevelopers.com/live. The speakers will be very happy to answer all your questions right after their sessions. And as always, please comply with our code of conduct. Here's a short video about that. In the meantime, I'm going to get our first speaker on stage. Hey Josh, welcome to WeAreDevelopers. Greetings to London. How's the weather there?
Very British, so not that nice, to be honest. Just a bit dreary and a bit cold, but it is what it is.
Okay. Do you get ever used to it?
No, not after I spent half my life in Australia getting used to much nicer weather. It kind of reset my expectations. So being back here is now worse than it was before.
Okay. Yeah, the Viennese weather here in Austria is not that much better, I would say, especially in the past times. So, yeah, I think we have just to deal with it. Josh, tell us briefly, what are you going to show us today?
So today I'm going to talk through a day one activity I've been doing on consulting engagements for a number of years now that's focused on trying to get a team to understand that continuous deployment is something that they want, something that they can achieve, and actually sets out a roadmap for getting there and is important for actually getting the team excited and chasing it themselves, as opposed to thinking that's for unicorns, that's for not us, where really it is. So hopefully it'll be helpful to people.
Okay. So Josh, the stage is yours.
Hello, everyone. Hope everyone's enjoying their Wednesday in the middle of the week. I think we're pretty much slap bang in the middle, so that's always fun. So as I just said, today I'm going to talk how you and your team can chart your journey to continuous deployment by using a value stream map. And I'll talk through what value stream maps are, where they came from. We'll even define what continuous deployment is, because quite often tech terms get overloaded and morphed over time. So just make sure we come to a common understanding. I always like to start these off with just kind of going over the key takeaways in case people stop listening to me halfway through, especially in these virtual ones where anything and everything can happen. I think it's always important to start off this way. So there are 3 key takeaways to take today. One is that value stream maps are about how you deliver. I don't really mind if you're using Jenkins, TeamCity, Circle CI, GitLab, whatever you're using. This is completely not tool specific and should never be. And I think that's really impactful and makes it a much easier thing to use. The second takeaway is that when it comes to software delivery, everything we're trying to do is to build confidence. And really, at the end of the day, software delivery is about confidence. And I'll explain that a bit more as we go through. And the third takeaway is potentially the most contentious of the 3, and that's that continuous deployment is a realistic target for over 90% of teams. I'll talk through in that 10% of where it's not appropriate, and even examples from my own past where I would never have pushed for continuous deployment because it didn't fit. But the upside is that for over 90% of teams, I truly believe that it is something that you should be aiming for and is realistic. So I have to do an obligatory about me slide, for which I apologize unreservedly, but I'm Josh. I'm the AWS practice lead at Contino for Europe. I'm a Amazon Partner Network ambassador. I'm a HashiCorp ambassador. I generally talk and write and far too much enjoy the sound of my own voice. So if this is interesting and you'd like to see more of the things I prattle on about on video, then do feel free to get in touch on Twitter, LinkedIn, anything that floats your fancy. So, as I said, I wanted to define continuous deployment just so we're all on the same page here, because I think we've seen it with Agile, we've seen it with SRE, we've seen it with so many terms that what they once meant is now not what they mean anymore. And it's always good to make sure that everyone's working from the same dictionary. So continuous deployment, as far as this is concerned, and I think this is a half decent definition, although it probably has room for improvement, is when you, from a commit being merged into a shared branch, it's deployed into production with no human involvement. There is no human involved in that process. And really, what we're trying to achieve is maximizing the amount of time we spend delivering value. So instead of doing rote tasks, time after time after time, deployment after deployment, instead we want to spend time on the activities that actually deliver value. And actually deploying software is not an activity that delivers value. When I introduce this with clients and teams, normally I like to explain the mental models that I use and the way I like to look at the world to explain why I then think this is impactful, because otherwise it's just a tool in a box that no one really understands why. So we'll go through a few of those now. The first comes from Lean, as does value stream maps, and I'll go into a little bit of Lean today. Unfortunately, I don't have time to do it justice, but I'll just pick and choose the bits that I can. So from Lean, you get the idea that there's 3 kinds of activity. There's value generating activities, there's necessary waste, and there's unnecessary waste. And when it comes down to it, if you can take all the activities you do and put them into those 3 kind of buckets, it starts to tell you what you should do about those. If it's value generating, we want to maximize the time spent doing that. And if you think back, that's continuous deployment is about maximizing the time spent delivering value. So you can see how this kind of hooks in already. And then you have necessary waste. There are certain things you have to do, but ideally you want to minimize those. And then you have unnecessary waste, which, as I think most people can normally guess from the name, that's something you want to eliminate. So hopefully, if people haven't seen this before, if you just keep it in the back of your mind, and I swear it will come back later on. Again, another thing that I think is really important is when you come into software delivery is, what does good software delivery actually look like? You know, is it the amount of, is it your velocity of your team across that sprint? No, I don't think so. How do you actually understand how your delivery process maps to others, where you are in terms of maturity and where you can go? And really, the best resource I found for this was in the Accelerate book from 2013 and the State of DevOps reports that DORA, the Research Association, and Google have been doing for, I think, 8 years now. The survey for this year's has just opened up. So if you're interested, please go put your data in. But what it gives us is a statistically verified, strongly correlated way of looking at delivery performance from just 4 metrics. So we don't have to measure the entire world, but also at the same time, we don't just have one God metric in isolation that can quite easily become gamed and actually be corrosive and toxic. And what you end up with is lead time. So that's the time for a change hitting a shared branch and getting to production, start to getting back to our definition of continuous deployment. You've got your deployment frequency, which, how many times do you deploy your software? Is it multiple times a day? Is it daily? Is it weekly? Is it monthly? Is it quarterly? There's somewhere in the world doing all of those. The time to restore servers is how long from a change making an impact until you can restore service. And the last is a change failure rate. How likely is it whenever you make a change to production that there will be an adverse effect, that service will be impacted from there? Now, the 4 metrics I put here with the less than a day, the multiple times a day, those are elite. And I will kind of touch back on that. But these are the best of the best. This is kind of where you're aiming for, to be amongst the unicorns and the best of the best. And it is possible to get here, even if you're not here now. And I've taken teams through that journey multiple times, and it's amazing to see. And this is one of the core tools I use to do that. And I argue, in order to be able to hit all these 4 and be elite, you have to have continuous deployment. I don't think you can do it without having continuous deployment there. You could throw many people at the problem, but it's not sustainable and not efficient. But generally, to do this, you have to have continuous deployment. It is kind of non-optional. And the last one I want to touch on before I dive into actual value stream maps is the concept of batch sizes and how this relates to DevOps. Now, I don't have time to go into the maths and the theory behind batch sizes, but effectively where it comes out is if you have smaller batches, every batch is less risky, you're able to move faster, and you're able to be more predictable. So if you can move smaller pieces of software to production, you'll do it with less risk, and you'll do it faster, and you'll do it more predictably. So you can start to see that there's something about batch sizes here and trying to get them as small as possible that starts to lead into getting that elite performance. Hopefully people can start to see that. And really one of the big things about DevOps and the reason we do CI/CD and all that kind of stuff is we're trying to optimize this batch size to be smaller. Really, that's where the benefit comes from. And when you look at finding your optimal batch size, there are kind of 2 costs that you need to look at here. You've got your holding cost, which is just the cost incurred by having that software not yet in production. So the key one I think here of cost is, at least, I don't know how everyone else, maybe they have better memories than I do, but if I've written code 2 weeks ago, to a large degree, it might as well have been written by someone else if I have to go and look at it again. And we all know that the devil in the detail in software is in production data, right? So getting it out there and getting that feedback loop and being able to see how your changes interact in production is critical. And that's where this holding cost comes in. The longer you hold on to that software and the longer it takes to get to production, the harder it will be to debug, the harder it will be to understand. And when it comes to transaction costs, that is all the effort that goes in from actually taking it from development to production. And when you do CI/CD and everything else, you employ automated testing and all those kind of good practices, effectively what you're doing is you're lowering that transaction cost. And as that transaction cost lowers, your batch size gets smaller to find the optimal point. And really what continuous deployment is doing is taking that transaction cost to the extreme, like making it as low as physically possible and seeing what happens. So now we've kind of framed the problem, and hopefully those 3 kind of ways of looking at the world will help people understand where value streams come in and where they're impactful. Now going to talk into just one aspect of lean. before I came to value stream maps. I swear I will. Just give me one more minute. So in Lean, which came from the Toyota production system out of Japan in the mid 1900s, they have this concept of this process for the Gemba walk. Now, where the Toyota production system came from was building cars, as you would expect, because it came from Toyota. And what people would actually do is go and look at the assembly line, watch the actual process of the cars being manufactured, and do that. Now, in software, we don't have something physical to go and look at, right? I mean, yeah, maybe you can look at your GitLab pipelines, but it's not quite the same as looking at your process end to end of how things work. So how can we take this Gemba walk process and the ability to take a non-judgmental view on how you work and how you can improve and bring that into software delivery? And when you look at how Gemba walks actually work and go kind of one level deeper, you end up with kind of 7 steps. And really what a value stream map is about hitting 4, 5, and 7 here. So being where the value stream is. So this is something that requires the whole team around a whiteboard, recording your observations, not making suggestions. So you just want to map reality where it is. You want to understand how things work now. And then when you follow up, you can get to future state. You can go, well, where do we want to be? How do we get there? What's that look like? So now we're actually going to dive into value stream maps. And again, hopefully this is all kind of starting to link together. So value stream maps can be a very deep topic in and of themselves. What I'm going to show here is a very simplified version of value stream maps, trying to Pareto principle this and go, what's the 20% of the effort that will get me 80% of the return? Especially when you're doing this with a team for the first time, it generally takes about an hour to do. This isn't 3 days of sitting in a room together. You can generally get a half decent representation in about an hour. And then you can really start to see benefits even from later that day. It raises a lot of questions, a lot of challenges, and going from there. So yeah, if you go and pick up a book on value stream mapping, you'll be like, there's a lot of stuff you didn't cover. And I'm like, yeah, that's kind of on purpose. I don't have time. And also for going through this process, you don't want to be spending a week doing it the first time around. What you're effectively going to do is draw the process from idea to value, from someone having an amazing idea that's ended up as a Jira ticket or in Trello or whatever tool you use, and how long and what goes on until people are actively making use of that feature, right? The annoying thing about software is until something's in production, it effectively has no business value. So that's the process we're trying to capture here. And because we all work in agile ways right now, effectively all you need is whiteboard and post-it notes, because that's how all decisions are made nowadays. Now, obviously, with the pandemic going on and remote working being a thing even before that, you can use Miro or Lucidchart or whatever tool floats your boat, whatever's in your company at the moment if you can't get together in person. But it's something that's quite simple. We're not doing anything overly complicated. It's more about the process, which is where the value comes in. Now, to start, draw a light bulb or some other symbol for idea at one end of the whiteboard and draw a symbol for value at the other end of the whiteboard. And what I like to do with teams is pick different colors for different branches, because normally the most impactful thing that happens in your software delivery process is how your branching strategy functions. So being able to easily see that is critical. And it also allows you to start seeing common patterns and start to categorize things very, very quickly. And effectively, what you want to do is follow the process for one feature from idea to fulfillment and in production. And what you'll end up with is something that looks a bit like this. Now, don't worry that you can't read this. I'm going to dive into particular points, but I just wanted to show it end to end. So you can see that we have idea going all the way through, we end up at value, and then there's even a bit after it's in production. And I think a lot of people that have been around the traps may be able to kind of look at this and kind of go, oh, this looks like Git flow or GitHub flow, something like that. You can start to see kind of commonalities and patterns very, very quickly. I mean, this isn't doing anything particularly amazing. You check out a new branch, you do a pull request back for the branch, you've got CI running, you deploy it to production. And if we dive in a little bit more on what happens once you merge the pull request, which when we come back for our definition of continuous deployment, it was from being merged into a shared branch and going to production with no human involvement. So if we look at where this team was, and this is just a typical example that I've seen many, many times, that you have this, you merge a pull request, there's a wait for the QA team to be available, it then gets deployed to a staging environment, there's some manual QA tests that goes on, and then assuming that's all fine, it gets deployed to production. And when we think back to those 4 metrics we talked about earlier, you see it's very easy to start calculating. If you can understand your process, you can calculate deployment frequency and lead time. And they're both captured in this part of the process. You can see how these things are all starting to link together a little bit. And when you look at deployment frequency and lead time, very commonly, if people are on an agile transformation and they've started using Scrum, or maybe they've got SAFe at the top level, and quite often what they can end up with is something that kind of looks like this when you start plugging the numbers in. They deploy to production once a sprint, so it's every 2 weeks, which gives them an average lead time of about 2 weeks. From merging that pull request, on average, it will take 2 weeks to hit production. Now, this is part of the reason for framing this based on those elite benchmarks, because this puts us about 10 times slower than where we need to be elite. If we want to be categorized as elite, we're about 10 times slower than where we need to be. So something's got to change here. And I also think it's important to note that this isn't something you can just increment an inch towards, because it's a 10x improvement. Generally, it's got to be something quite substantial. Like, it's not going to be refining this process that will get you there. It's going to be another process or making some radical change that's going to get you there. I just want to quickly I said this was all about confidence, and just kind of talk about that. So when we look at that stretch, what are we actually trying to achieve? What's the thing that stops us from going, yes, this is okay to go to production? And really, at the end of the day, it's a confidence that the value of doing that release outweighs the risk of doing that release, right? We want to be sure that we release this new feature, we're not going to break other things. The risk of breaking other things is low because we've done sufficient testing, and the value of the feature is high because we're making sure we're working on the right things. So really, when you look at this process, effectively, all you're trying to do is build confidence. Testing doesn't prove the non-existence of bugs. It makes you confident that there aren't bad enough bugs that should stop you, right? Like, unless you go through TLA plus and those kind of ways of looking at software systems that are high investment, testing is all about getting confidence and being confident enough. You can never be 100% confident, right? So let's kind of look at the process that we had and look at where it is we're starting to get this confidence from, because in order to move faster, we need to get confidence faster. And really, where are these points where we're actually getting this confidence? And there's kind of 4 I've outlined here. One is the continuous integration run that runs all our unit tests and maybe some integration tests and all that kind of stuff. So that's quite an easy one to see, is where you get some confidence. And the second is the peer review. So having another person look at the code, going, yeah, that looks okay to me, challenging certain points and all that. So we get confidence from those. And the other part where we get that is the manual quality assurance test. And I've also included the waiting for the QA availability, because really that then leads into how long it takes to get the feedback loop from quality assurance. Is not just how long the quality assurance tests take to run, but also the availability of the people to do it. So when you're looking at your bottlenecks here and trying to analyze your process and put numbers to things, it's important to make sure you capture the wait times as well. And these kind of numbers that I've kind of averaged out from doing this a number of times, but effectively, you've got your continuous integration run takes 15 minutes. Yeah, you can optimize that, maybe get it down to 10, but that's not really going to move the dial or the needle, right? You've got the peer review, it takes a couple of hours. Now, me personally, I'd like it to be a little bit quicker than that, but also when you then look at the QA testing and the fact that you have to wait on average 5 days and the regression suite takes 2 days to run, optimizing peer reviews is pointless because they're not your bottleneck. They're not what's dictating how fast you're getting this confidence. It's coming from the manual QA test. And it's not that what the QA team is doing is not valuable, and not that running these regression tests isn't needed to be done, because you need it to get that confidence. But I think what should hopefully be fairly obvious to people is the fact that quality assurance is something we need to look at. And where I always end up with this, and normally coming in as a consultant, or if you're trying to facilitate this, you want to be trying to coach the team. You don't want to suggest answers. You want to be advising them, helping them come to things themselves. And quite often teams can go, well, what can we do about quality assurance? And, or what should quality assurance be doing in the very front of it? And this is generally where teams end up. And to be honest, I will normally nudge them in this direction if they're not getting there. But manual QA should be purely exploratory, and all regression testing should be automated. You shouldn't have the same test being done every time you want to deploy or on every change that's done by hand. Because as you move fast and as you're starting to deploy, ideally look to deploy multiple times a day, you just do not have time to wait for this. You don't have time to wait for people to be available. You don't have time to wait for them to run these tests. So really, they normally end up in these bits. And if we bring that kind of back to the activity type model that we talked about before, that QA testing is necessary waste. All automated testing is necessary waste. We need to do it to build confidence, but it doesn't directly generate value for the end user. So this is something we want to optimize. And normally by optimizing, in technical circles, we mean automate it away, right? But the waiting on QA is completely unnecessary waste. And the really nice thing about automating this is that wait time also disappears, because if it's all automated and we look at what we can do with exploratory testing, then we can change this dynamic, and that 5-day waiting time completely disappears. And also that QA testing run that was taking 2 days can probably be brought down to, I don't know, an hour, maybe less than an hour. But you can look at how you can build that confidence in other ways and automate it away and put it in different parts of the process. So you can remove this bottleneck. And normally after this, once they've kind of analyzed this, I like to play the game of where would you like to be? What's the future state? If you could kind of blue sky thinking, what would you want like your process to look like? And often what they end up with is something like this. So again, I'm going to dive in a little bit. Please don't try and read everything here. But even at this kind of zoomed out level, development branch has disappeared. We don't need that anymore, because really, when you're doing Gitflow and GitHub, the point of the development branch is to add more stability to a particular branch so you have time to run manual QA testing. That's really the whole point of that branch existing. So if you get rid of that, then all of a sudden you don't have to have development branch, and trunk-based development becomes a real opportunity here. And I have my very strong personal opinions on this, but I find trunk is a much easier, simpler, quicker, and more efficient way to work than Gitflow. And this is one of the reasons why. So if we dive into where we dived in before, we'll dive again and look at kind of the same point. So from having a pull request merged, we deploy to a staging environment. There's an automated QA test that runs, and assuming that passes, we can go straight to production, because we've got enough confidence to be sure that the value of the release is outweighing the risk of the release by a sufficient amount. Therefore, go to production. We're happy. And also we have exploratory testing happening after it's gone to production. So where I was saying before that the devil's in the detail with production data, you can do exploratory testing with production data. You know, the testing in production, to be honest, we all do it all the time. And it's not that testing in production is bad. It's only testing in production is bad. You need to test before you get there and test after you get there, in all likelihood. So when you have that QA team who want to test things, have them test in production. And this is where all these, you know, tooling and options and processes like feature flagging with launch darkly or something like that, canary deployments and blue-green deployments start to make a lot of sense, because those are about de-risking that production release by, you know, you lock things behind feature flags. So only QA can see it at the moment, so they can do whatever exploratory testing if they want. Or if you're making like a big change to a feature, then you can canary roll it out, make sure that it's still succeeding and people are still able to succeed on trying to do what they're trying to do, but you can reduce the impact. And blue-green, is kind of the easiest, the simplest to implement one of these, where effectively, if there's an issue, just roll back to the previous version. But what this means is you can start to make decisions based on the feature going through as to how quickly it can go to production, what exploratory testing needs to happen. Like if you're doing a minor change, maybe there isn't really exploratory testing, in which case it's straight to production, straight release to all users, and you're happy. If you've got something riskier, then you can meter it out slower, but you retain optionality here to decide what you want to do. Whereas when you had that kind of shared develop branch, you're deploying every 2 weeks, you're kind of forced into deploying everything at once, which means you have to treat everything with the same broad brush. You can't be mindful and decisive about what it is you want to do. Now, I did say I would talk about why not continuous deployment. And I'm going to use a story from my past, from a previous life on this one. So if you have an inherently high risk of release, as in there's nothing you can do about it, and it is just a high risk of release, potentially depending on what it is you're working on and the impact of a problem, or inherently high cost of change, which is the one that I've unfortunately suffered from before. So in a previous life, I was working at a startup, at a machine learning startup, and the deployment process for our software out to our clients, which was deployed on site for them, was a 20-hour round trip flight for me, flying from Australia to the Middle East and back every time we wanted to push an update. I really didn't want that software to break on me, or that upgrade process to break on me while I was in a server room, about 5-hour time difference, and just kind of working away by myself to get all this done. I really didn't want that to break. And when it did break, my God, was I unhappy. So at that point, from an operations perspective, we wanted that stable branch because to build the level of confidence we needed to achieve and that cost of change, we needed to be incredibly confident because the cost of change was really high and there wasn't really anything to be done about it. So in that case, we did use Gitflow and we had stable release candidate branches that we maintained because I pretty much spent 2 weeks thrashing it every way I could, and tried to automate as much of that as possible. But still, it was just a case of I didn't feel confident and I needed to get confidence before I was willing to hop on that plane and have it blow up my face on the other side. But yeah, the inherently high risk of release, like if you work on critical infrastructure, like sometimes like telecommunications for emergency services, yeah, you can't do continuous deployment. But really, when you look at it and working in enterprises, startups, or especially stuff deployed in the cloud nowadays, your cost of change should be near zero, and your risk of release, again, is normally near zero because you're not dealing with anything quite so critical. If you are, then you'll need to be more mindful and maybe picking a different branching strategy and looking at what you can do, but that's quite specific. The one that I get told of occasionally that I get annoyed by is it's too expensive to get there. We can't build the business case around getting there. As I said, if you're deploying to the cloud, chances are your cost of change your inherent cost of change should be incredibly low. And really, when it comes down to it, according to the numbers, 20% of teams are already here, and that number grows every year. So this isn't a case of if, it's a case of when you'll need to be here, really at the end of the day. And often it can sometimes be hard to sell into the business because this is a lot of time not spent on features, but on the process to deliver features, right? And really, when we're talking about this, it's about lowering batches. It's about making the delivery process less risky, faster, more predictable. Now, what business in the world doesn't want that trifecta on their software delivery and their systems, right? So there are ways of selling this in. And at the end of the day, I honestly think it's too expensive not to do it, because you'll have to go there eventually and you'd rather be at the front than at the back. So I'll just quickly sum up on the takeaways, and I think there's a couple of questions, which is good. So the first takeaway was value stream maps about how you deliver. They're not about what you deliver. They are working on the process itself, the process of delivery, not what you deliver. The second is it's all about confidence and building that confidence, and that is beyond writing the code. Pretty much everything else you're doing is all about building confidence that the value is right and the risk is low. And the third is that continuous deployment is a realistic target for over 90% of teams. Hopefully I've convinced some people for that, because normally I get a bit of resistance here on that. So hopefully people are seeing it in a different way. But that is the end of my slides.
Okay, Josh, thank you very much. So let's see if we have some questions coming in. Yeah, there's actually one very general question. Maybe you have a take on that. How would you measure success of DevOps practices? Or
I honestly think those 4 metrics is the best option we have. They are at the end of the day proxy metrics, but having a look at lead time, change failure rates, it's what I coach my clients into looking through through the lens at, and looking at if you can get those 4 metrics going up, then you're doing better. The nice thing with those 4 metrics is if you try and gain one, it will negatively impact the others. So you kind of can't cheat the system very well. And having worked in teams where you are elite, it's a lot of fun, and it's a very happy team to be part of as well. And I always like leaving teams happier when I leave the consulting engagement when I started. So looking at those metrics, looking at the state of DevOps reports, they're the best measures for DevOps that we have to date. There may be better ones coming along, but as far as I'm aware of, they're the best that we have.
okay, then there is one thank you, and then there is another question. Any advice on how to convince your team to do continuous deployment? I mean, your whole presentation was about that, but I always also hear people saying, yeah, we would need to do it, but we don't have time. There is arguments against it. So is there any kind of killer argument? I mean, you said, for example, it's too expensive to not do it, but yeah.
Yeah, I think a lot of the time, I mean, I always try and find numbers to try and build my case around on this kind of stuff. On the team, if you've got kind of engaged engineers, normally they want to do this. Normally the challenge is getting the business buy-in, which can be challenging, but also another way I like to look at the world that isn't part of this, but is part of kind of other stuff I do, is the flow metrics. So analyzing what kinds of work your team is doing. So you have in there's kind of, I don't know why it's always 4, but it's 4 again. So you have defects, you have risk, you have debt, and you have features. And effectively being able to categorize all the work you're doing, and being able to show movement over time. So if you're working in a way that's inherently risky, you'll see a lot more kind of defects coming back through as work, and going if you let us work on the process, you can get a better ratio of these. You can get more features, but less defects for that, which gives you more features in the long run, right? It's, I find startups are normally very easy to convince of this. Enterprises can be a bit slower, but sometimes it's finding one little bit of the code base, one little bit of the system, and go, we're going to do continuous deployment for this, and use that as an experiment to kind of build momentum. I've done that a lot of times when they're using Git flow, and I'm like, okay, I'm going to use trunk on this little bit, this new little bit, and then we'll kind of contrast and compare in a couple of months to see which one we think evolved better over that time and whether that was impactful. So a lot of time it's finding that little space to start building that momentum.
Okay, then let's get back to the Q&A tool. Okay, there's another thank you from Wahid. Thanks, Wahid. Then do you feel a lot of resistance and differences when consulting smaller companies versus bigger companies? You just said something about startups, that it's easier, right?
Yeah. When I've worked with startups before, they're generally easier because there's less history. Is normally the bit that I normally get not angry, but if people say that's the way we do things here, I'm like, that's not an argument. It's a statement, but you're not allowed to use that in an argument, right? Yeah, you do hit a lot of resistance at companies. I think it's understanding at the end of the day that if you're not hitting resistance, then you're not actually making change happen. So you've just got to be aware that resistance will happen. Yeah, bigger companies, it's harder. Again, it's all about finding the wins to build momentum and try and cascade it through. But it is difficult. The bigger the company, the harder it gets. But at the end of the day, bigger companies generally have more money to afford more people to try and enact more change, but it's finding the pain points or the right part of the business that's trying to move faster and helping them, and then being everyone going like, well, how come they're working so well? And then that's worked quite well. And before that, you end up if you take the team down this path, they end up being the team that everyone wants to be, and then change starts to happen without you having to do anything, which is quite nice.
Okay, yeah. I would have assumed it's harder to convince startups because, you could hear some things like we don't have time, we have to do other stuff, we don't have the money right now, we don't have the resources. But yeah, interesting to see that point.
Yeah, startups are normally pivoting all the time. It depends on exactly what stage.
Yeah.
But often, like I've helped startups go from like day one to exit by kind of going, no, this is how you're going to do software from day one, and they're like, yeah, we don't think we would have got there had we done it any other way in the first place. But building that kind of rigor in at first, because it is always harder to bolt on. But you can't add quality later. You have to build it in from the start. So it's really, yeah. I don't know. It depends on the nature of the people,
Yeah,
the company.
that's a good point. That's a good point. Then there's a question about the slides, if they will be available for download. Yes.
Yeah. I'll need to throw them somewhere. But yeah. I don't know. You can find me on Twitter. I'll put a link out on Twitter and LinkedIn later today. I've got a GitHub repo which has a whole bunch of different slides from years in there, so I'll make sure that there's people can grab them if they want.
Perfect. Yeah, that was actually the last question already. Is there anything else you want to add?
No, not really. I feel like normally people get sick of me talking after 40 minutes, so it's probably good if I stop now.
I enjoyed it. It was a very nice first session with a kind of also, a bit of high level information, and also trying people to get the bigger picture on these topics. So I found it quite interesting, and hope to see you soon again also.
Yeah. Hope to see you soon. Thanks for having me.
Yeah, thank you, Josh. Bye.
Cheers. Bye.
Okay, that was our first session, and we are basically going into a very short break, and we'll start again at 2 p.m. sharp with our next session, GitLab CI pipelines for a whole company. So looking forward to that, and see you in a couple of minutes. Welcome back to our next session with Martin. Welcome, Martin.
Hi, thank you for a warm welcome.
Martin, where are you joining us from?
I'm joining you from Prague.
Beautiful city. Been many times there. How's the weather there?
Weather, kind of cloudy these days, so.
Cloudy, but no rain?
It was raining at the morning, but nowadays it's just cloudy.
Okay.
It was really nice yesterday, but those days are gone today.
Then it's the perfect session to watch an online session, right? That's
Hopefully.
the perfect time.
Yeah, I guess.
Okay. Martin, what will we learn from you today?
Hopefully you will learn a bit about how to share your pipelines in a company which has a lot of projects, and how to maintain it, what are the lessons, what are the principles you can apply. So that's going to be the thing I'm going to talk about.
Yeah, looking forward to that one, Martin. So the stage is yours.
Okay. Hi, everyone. My name is Martin Beranek, and I've come here to talk to you about GitLab CI pipelines for a whole company. I'm from Aki, which is kind of bizarre name. So let me just explain what's Aki all about. We are a software house. So usually customers go to us, give us their user stories. We analyze their situation, and based on the explanation we got, we create wonderful applications for them. We like to think about ourselves that we are a very agile, fast-changing company who isn't these days. We like to standardize a lot. That actually help us a lot to make a lot of fast changes. And there's, of course, a very little sentiment for operations department, as it is usually. Also, Aki is a Jamaican fruit. So if you are trying to Google us up somewhere, be prepared to scroll a bit, because usually we are not the first ones at the Google search. Just to give you a small summary of what we are, who we are. My boss is going to watch this later, so I have to tell this anyway. Just bear with me, it's going to be pretty fast. We were established in 2012. We have 250 projects under our belt. Plenty of those are still supported and maintained by us, especially by operations. Which is currently counting around 5 members. So it's just me and 4 other colleagues. Otherwise, we have 70 plus people. And those numbers are still growing up. We are really happy about it. And also we work in Germany and in Czech Republic. We are not, I think, that bad. We actually receive few awards. So for those German listeners out there, you can download Bundestag app, which was designed and created entirely by Aki. We also received some awards for it. So hopefully it's not that bad. So if you want to know what we are up to, Bundestag app is something, it should be pretty nice. Who am I? Well, I said it. I'm Martin. And I do not really like to introduce myself. So if you are interested, just check my LinkedIn. Otherwise, I like Python, Kubernetes, serverless. I love beer. Come on, I'm from Prague, Czech Republic. So it's kind of must in here. And also I work on my pipelines almost every day. So hopefully I have something interesting for you. So I'm going to talk about why did we decided to use GitLab CI at the first place? What are the principles you can apply from our approach? What are the lessons we learned throughout of the development process? So what was there at the beginning? The thing is that in 2012, you had very limited opportunities to which system you should choose. So basically, we went with the flow. We just choose Jenkins and wrote everything in Groovy. Back then, there was almost none expectations about the pipelines. Our ideas were pretty limited because we didn't know what should we prepare. So the code base kind of got really messy in a few years. There was no documentation. People who wrote the code already left. So there was no responsibility either. Development teams were responsible for writing the pipeline. So for operation, it was more or less just by fixing the issues developers created. There was no versioning, so once you merge everything into the master, it was done. It got seeded into the Jenkins, and that was it. I've put there small snippets of the code just for you to give you a wider imagination what we are dealing with. I love this part because we actually even failed at failing. Somebody just forgot that exception got an attribute called message. So it was a mess. And, you know, I don't want this talk to begin in a well as negative way towards Jenkins users. I think Jenkins is a wonderful system. For us, it got just really cluttered during those years. And at the end, we were solving a lot of puzzles. And I put here this quotation from Alan Turing. And I know he's not talking about code like Python, for example. He was talking about entirely different codes. But for us, most definitely being in operations and supporting those pipelines was a puzzle on daily basis. And it was just a huge mess. The struggle was just real. No new people were too keen to adapt to our code base. You know, they were joining quite recently. So, for example, I joined last year, and when they told me that I'm going to work in Jenkins, I wasn't too happy, I guess, especially nowadays when you have so many alternatives. Our code base did not do the trick either. The people just discovered how messy it was and were not really happy to maintain it. So in a way, there were never not enough people to make any reliable changes, rewrite everything and start from the scratch. So for us, most definitely, this became a toil. So what actually led to a change? Why we decided to go in a different way? Well, it was quite simple. I just put the hours we spent on support and on the development on the paper, multiply it with average hour of a DevOps engineer. And with that, I went to the management. And somehow, once something is really costly and expensive, obviously, it's kind of easy to make the decision and leave everything behind and start from the beginning. So what was there before the rewrite? Each platform has its own standardized pipeline. That sounds nice because each platform could be recycled. So developers just need to fetch some kind of template for a new project. And the pipeline would be utilized in the same way as it was in the project in the past. Each development team was back then managing their own pipeline. We were there just in case they had some kind of issues. So in a way, this led to a large amount of frustration because we were not responsible for the break-in features, but we were responsible to fix those features. So it was not really happy cooperation, I guess. And some other factor to count in is that our platforms vary from iOS to Node.js. So in a way, I'm always doing this running joke when somebody's entering our team that we are jack of all trades, master of none. Once you are working on support, you just have to understand a bit about everything, but somehow you just sometimes miss the big picture and miss the knowledge of a deeper situation and the things which can get broken. So what actually always worked and what we actually wanted to keep in the future. We found out that having monorepo is a good way to manage multiple pipelines. You can share the pieces of pipelines. This actually speed up whole development, whole maintainability kind of, works with it as well. Not all developers need to understand a whole pipeline. Especially junior developers, they just need to use it. So they just need to study some general guidelines, some how-tos, and fill the input variables, and it should work for them. Of course, undocumented decisions lead to misunderstandings, and I can't stress this enough. It's usually in all the conferences, there's at least one lecture about documentation. So it is important, and for us, it was a thing which we really missed in our we've written pipelines for Jenkins. Developers cannot merge changes unless operations understands those changes. That's the thing which is related to operations, and that we should be responsible for the features and not just for the fixes. Well, our expectations were pretty high. We wanted the code to be self-explanatory. The description shouldn't be the obstacle to use the pipeline. It should be clearly written README. 50% of the time should be given to the support at maximum. That's not from my head. That's from SRE workbook written by Google. So keep that in mind if you are, designing some kind of system. This is a really important factor. Pipeline logic should not fail by itself. That's kind of hard to do in Jenkins, but it can be managed. And of course, always apply KISS principle. And I know the original meaning is keep it stupid simple, but in a way, I don't think that actually works. Have you ever tried to call your grandma and explain to her over the phone how to connect a printer? Like, nothing in IT is simple. We like to think about it to be as simple, but doesn't really work. So I think this version is better. Keep your infrastructure simple and standard. And the same goes for pipelines, obviously. So what are the building blocks? And this is going to be a small summary. I'm aware that all of you, or vast majority of you, already know what's pipeline, how it works, and so on. But let me just give you this quick overview. So pipeline usually consists of stages. Those stages are executed sequentially, one after the other. And each stage contains multiple jobs. It can be that easy. This is an example of a job which is there in the stage deploy, and it just says deploy link, like there is no tomorrow. Hopefully somebody is going to give there the implementation tomorrow, but we have to wait for that. But it's never that simple, obviously. So this is our production pipeline. This is a pipeline for Node.js projects, and it's divided in two parts. So this is the first part, which is more or less related to code base. So we build our Docker image. We then fetch our secrets from Vault. Then we do a battery of tests. Those are npm audit, lint, hadolint for checking a Docker image, tests, and so on. And the second part is related to cloud operations. So we then take the image, push it into the Google Cloud registry, then we validate the deployment. And once everything is all right, we then deploy it into the Google Cloud's Kubernetes engine. And once everything is done, we then generate the documentation and put it into the Google Cloud storage. And as I said, it's never that simple. This is kind of new old feature. It's called DAC, and it got renamed into the needs. So in a way, it's just a representation of the pipeline as a directly acyclic graph. And it's just a solution to this minor issue. Let me just explain. Usually I have multiple jobs in a stage, and those jobs take a different amount of time to finish. And if you can somehow break this constraint that the jobs have to be finished and then other stage will continue, it's going to speed up whole pipeline. So in here for GitLab CI, you can specify need statement in the YAML file, and in that need statement, you will say what are the dependencies in between the jobs. So once the dependency for a job is fulfilled, the job could be executed regardless of the stage, which is the job part of. So then you can have this wonderful chart. I think it's not that self-explanatory. Nowadays, you can of course see those relations in a pipeline UI tab directly in a GitLab server, which are much more readable. So it actually works pretty great. So what are the principles we applied? Yeah, I know we arrived in a time of principle. I know it's an entirely different word, but I'm not a native speaker, so for me, it sounds almost the same. And it's the first cheesy picture I have. There's two more, so bear with me. So what are the principles we apply? We do like to recycle, of course, Europeans. We like to explain stuff. We make people responsible. We document the pitfalls. We customize the runtime, and then we analyze. So what do I mean by saying recycle in context of GitLab CI? Well, as I said, we usually have only one pipeline defined in monorepo, and those pipelines should be included into the projects developers are working on. So you can always utilize this include statement. It's GitLab CI specific. It's not YAML rated. And this include statement works somehow as a merge. So if you have something in your GitLab CI file, it's going to rewrite the file you are going to include. So in this example, we include a Node.js pipeline, which is part of GitLab CI templates project, and we refer a master branch. This is, of course, not a good practice. You usually do not want to refer a master branch. So we always put there reference to some Semver version in our repository. Of course, we do like to explain a lot. So in this example, there are two jobs which are not related to code base. They are not contributing to cloud operations. They are there just because we need to do some kind of auxiliary tasks. So in this case, we just download some kind of helper functions, which are then shared throughout the pipeline. So some people might be tempted to remove those jobs entirely because they are not contributing that much. It was especially my case, I did it. And then I wrote a very thorough explanation why are those jobs in there and why it's a good thing to leave them there and how to work with them. So yeah, you can spare some people a whole afternoon just by explaining the stuff in the correct way. We of course like to make people responsible. So these are the first two lines which are part in every pipeline definition we have. And those are saying just the name of the pipeline, obviously, and of course the name of the responsible person for the reviews. And there have to be always somebody who will say, okay, we're going to merge this. This is good enough. It's going to work for us. And all the constraints given to us by this monorepo are fulfilled. Let's just go. So, I was given a task to write a pipeline for iOS applications. I do not really own any Apple product. So for me, it was pretty hard. So that's why I put there, remove me as soon as possible. Because if you do not understand the technology, the whole thing kind of, backfire pretty fast. So I was really happy that somebody else came in and just changed me in that position to make the pipeline better for the future. And it kind of works. We also have this special pitfalls paragraph. Pitfall for us is a statement saying something is not working in a way it's obvious. So basically it's somewhat a workaround in a situation. So we describe the pitfalls in the small statements, sentences, and then we put there an issue which relates to the pitfall we already have. Once the issue in the upstream GitLab project gets resolved, we then can go and update the pipeline and move everything forward. Of course, you can always customize your runtime in a GitLab, and this is done by using Docker images. So in this example, we usually have a lot of infrastructure repositories which somehow get a different version of Terraform. So back then we had just a pipeline with a statically fixed version of Terraform. So it got kind of messy during the operations time. So we put there a variable which can be defined entirely differently for each of those repositories. It kind of backfires once you forget to put any value in that variable. And the explanation from GitLab CI is not that self-explanatory, I might say. So if you ever found out this issue, or you will see it in the future, just be aware that you forgot to put anything in the name of the image which should be executed for a job. we of course run our tests. We picked Docker Compose for that. We use it because we are able to execute those tests on the local machines. Developers are familiar with Docker Compose usage, so it kind of works for us. In the pipelines, it's a kind of different story. Docker Compose is not that well supported as well as Docker is. So you would probably have to do some kind of workarounds and some kind of fixes of your pipeline. You can choose alternatives. Those are called services, and services are started during the beginning of job runtime in the GitLab CI. So you can define there all the services you would need. MySQL, Redis, you name it. The thing is that you can't really use it on a local machine and local development. So that's why we choose the Docker Compose. I would strongly recommend using environments. And this is a feature which has been there for a while now. I know that plenty of us have development, staging, and production. For some of us, those are entirely different systems, which is nice. But in case you would need more environments, let's say development is currently used for some other feature and it can't be broken, you can then use these GitLab environments. Those are usually referred by variable, by URL, which is then displayed in the GitLab UI. And you just need to know how to create an environment, which is defined by a script, and how to stop it. So then you can see it in a UI with this deploy and stop button if you prefer to start it manually. So your quality assurance teams can go there, investigate everything, and once they are done, they can merge request, and environment disappears. You can utilize YAML magic. That's kind of cool. I showed here only the example with anchors. Those anchors are just there for a single file. So if you are planning to use include statements, those are not going to work. So be aware of that, that you can repeat this code only in a single file. We do perform static analysis. So in this case, we use Danger, and Danger actually help us follow our company guidelines for a Git flow we have. So these jobs actually execute in a merge request and create this wonderful comment in our UI. So in this example, my commit message was just too large. My branch got named differently. So I could fix this before any other developer will go there and create a review for me. So that's a speed up in the development. So now we arrived in the town of expensive. There's a second cheesy picture I got. It's going to be a third one. Be prepared. So what is expensive in a GitLab CI? And for me, most definitely for our use case, sharing data is expensive. You can use caches and artifacts. Caches are usually a bit faster. Those are hosted in usually object storage. In this example, it's a S3 bucket. And otherwise, you can use artifacts. Those are data uploaded into the GitLab server via HTTP, and it kind of take a while to upload everything and then download it in the job you refer to those artifacts. Everything works great for reasonably large projects, but then I've noticed that our pipelines are actually a bit struggling, and I noticed that we have these large folders called node modules, and they are just a nightmare. I don't know how about you, but they are just a mess. Thousands of files, really large, really hard to let's say compress and push somewhere. And I thought that's kind of a mistake. Somebody put there a lot of dependencies, and now I have to struggle with it. But then they told me that this is entirely fine. That this is how the ecosystem actually works, and node modules folder is the heaviest object in the universe. So I should deal with it, not just blame somebody else. So yeah, be prepared to deal with undealable, I guess. So we kind of created the local caches for those packages. we noticed that obviously all of those package managers save those packages in some kind of folders. And then we created volumes for those folders. So those are then mounted to the runner's runtime. And once the package is already there, they are not downloaded for the second time. So that was a speed up. You always have to think about the package managers being able to handle concurrency. So in this example, we can see Carthage, which actually had some kind of issues. So we put there a one-liner, which creates a log file. And once the log file is released, other job can continue and so on. To further tackle Node Module's nightmare, we introduced Verdaccio as our local cache with NPM packages. It kind of helped us speed up everything, and especially last year, having a local cache with packages was really helpful because upstream registries had a lot of issues due to high load and, of course, Corona times. So that actually helped us a lot to keep up our availability for the developers. That's the third cheesy picture I got for you. It's really old, and I really enjoyed it every time I look at it. So once I was creating the presentation, I was thinking, oh, lessons learned. What should I put there? So I put there something describing how we got burned, so you wouldn't have to. So yeah. So what are the lessons we learned? Of course, educate your developers. They are going to love it. So in this example, we created a job in a pipeline which just checks the size of the Docker image. And once the Docker image is just too large, it will fail a whole pipeline. For us, too large was above 1 GB. Then they told us that we are bad. We should remove it entirely. So we put it there in a way that the job can fail, but the pipeline will continue. So it kind of works. We, of course, utilize Renovate. If you haven't seen it anywhere, it's kind of hard to miss it. But to give you a small summary, just check upstream versions of available packages, compares it with the packages you currently use in the project. And once there is some new package, it will create a merge request for you. And once merge request is created, a new branch is also created and the pipeline will be executed. So in here, we can see that almost all of those merge requests could be merged without any large consequences because the pipeline got executed, all the tests covered everything, hopefully, and we then can merge away and move on. Of course, as I said, we work in a monorepo, so do not rush things. In here, we can see an example that I rushed something in my beloved iOS pipeline, and I had to do some quick fixes and push them into the master branch. The thing is that those fixes are going to stay there forever, or at least until we are going to rewrite to something new. And they are going to mess the Git history for anyone else trying to find something. And if you're interested in those emojis at the beginning of the Git commit message, those come from Gitmoji. We are big fans of the project, and it really helps us understand the repository faster, not just by reading all the commits. So, wow, I'm really fast. So let me just draw a few conclusions. At the beginning, I said that we were expecting that our hours are going lower and lower. So these are the data from last year. So at the beginning, we struggled with Jenkins. It kind of got better and better. And in the middle of the year, we decided to switch to the GitLab CI and start whole migration process and rewrite everything. So nowadays, these data are kind of the same as they are in the end of the year. We are spending roughly about 8 hours a month on our pipelines, and we do not support Jenkins anymore. So it kind of works for us, and it was a good move in this case. Our code base got mainly better due to usage of YAML, because we just define things. We don't need to write any structural code. Poor code base got sometimes hidden into the Docker images, which usually contain some obfuscated scripts, which are managed not by operations. So it's not under our radar that much. but we are trying to fix that and improve upon that. Moderator helps us to make the mistakes visible. So in a way, as I showed to you in the past slides, everything is visible. Everybody could be called upon to explain why it's like this and what is missing. People are responsible, and they are actually written directly in the documentation. So it's not like they would be saying, "Oh no, I didn't know." They have to approve to be written there. So it kind of works for us. Sometimes, obviously, it has its moments. Everything has its moments from time to time. Due to some legal reasons, we had to bought some runners and we put them into the closet in our office. It's kind of funny. Usually you hear that people traded CapEx for OpEx. We traded OpEx for CapEx. And if you need remote hands, for example, something break down, you can just give a call to receptionists. They are fully trained, so they know how to turn the machine off and on again. And it kind of always works. You don't need anything else. And it's a great source of great many inside jokes. So it's a lot of fun. This is one of my last slides, and I wanted to, create something for the people who actually contributed to GitLab, or they have some kind of say in what way it's going to move in the future. And I kind of name it a wishful thinking, the things I would really enjoy to have in our GitLab CI. And they are not there, or they are not implemented in the way we would like them to have it. So if there is somebody from GitLab, could you please integrate HashiCorp Vault instead of plain variables? We usually have HashiCorp Vault for almost every secrets we provide. So for us, handling those Vault fetch commands and Vault push and so on, it's kind of administration which could have been done just by integrating HashiCorp Vault and just removing variables entirely. Of course, if variables could support maps, that would be also great. Nowadays, they are just a plain list of variables, which is the same for different branches. And our Git flow is branch driven. So for example, if you want to deploy into the stage, you would merge into the stage branch. So for us, it would be better if we would be able to switch entire set of variables just by saying, utilize this part of map containing the set of variables for the stage branch. The rules are just complicated. Those are the rules which are evaluated once you need to execute a job. You can always use except and only conditions which are there. Those are supported, but the rules are kind of something new, which can get a bit complicated, and it's really sometimes really hard to understand those rules, especially if the rules list is too long. And of course, I have to say this again: sharing caches and artifacts is kind of slow. So in a way, if you could introduce workspaces from Jenkins back, it would help us in some cases as well. So that would be also really nice. And that's it from my side. Thank you for your time. Thank you for listening. Hopefully you found something which was interesting for you and you will apply it in your job and it wasn't a waste of time for you. So yeah.
Martin. Thank you, Martin. Very nice presentation. Also very nice wish list. So let's see if someone listens. We did have speakers also from GitLab joining us in the past. So maybe there is some success. So nice. Let's jump into the question. There is only a couple of ones, so there is multiple thank yous for the presentation, and then one question very quickly: what package manager do you recommend?
Package manager for which use case? We kind of leave it for the developers because, for example, for the front end, they are familiar with using Yarn. For the backend, Node.js people somehow prefer NPM. So it kind of depends. We do not really like to enforce anything on the developers because it usually won't work. So it depends on the pipeline.
Okay, then next question. Is there something in Jenkins that would make you switch? I think it's 7 minutes old, the question, so I think it was when you were talking about the last slides.
I think it's kind of hard, I think for us, the Jenkins wasn't the main issue. Our main issue was our miserable code base. And switching back, I think if there would be some kind of tighter integration with operations, which actually GitLab has, and it's really nice, that would be really great. There are plenty of reasons, and I do not really like to write the things in the Groovy because usually I messed up and it cost me a whole afternoon to fix the thing. And this is not about Jenkins, it's just about me writing the code and do not understand how the things works. But I think for learning curve and for people who like to contribute into the pipelines and they just want to create some kind of jobs and make the things done, GitLab CI is just a better way. So currently, to answer the question, I don't think there is anything I would consider like game changer for us to say, oh, wow, we missed that. We have to switch back. We have to rewrite everything. It's going to be amazing and it's going to work for us. Yeah.
Okay, and the last question. What are the KPIs you measure for your team?
That's a tricky question. I'm not entirely sure if we have something like KPIs entirely like defined. As I said, we are very agile, so it might change a lot. But for perspective of support, we always like to measure how fast, how much time it took us to fix the issues, and based on that, we made a lot of decisions on improvements of the pipelines and so on. We also provide some kind of SRE work as well, but those are not really related to pipelines. So it's kind of a tough question. I have to ask my boss, what are our KPIs and
how do you measure my performance?
How do you measure my performance, and are you happy about it? That's going to be a great conversation. Thank you.
Okay. Yeah. Good. Then Martin, thank you so much for this presentation. We are going in a short break again, enough time to get a coffee, and then at sharp 3 p.m. we are going into our next session about infrastructure with CDK and TypeScript. So looking forward to that one. Martin, thanks again. See you soon.
Thank you very much. Bye.
Bye-bye.
you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies...
Welcome back, everyone. So we are here with Robert. Robert is a senior solution architect at Amazon Web Services. Welcome, Robert.
Hi, thanks everyone.
Hi, do you have also bad weather like all the other speakers today?
Yeah, I'm afraid yes. So it's rather mixed, I have to say.
Okay, so you are joining somewhere nearby Frankfurt, right?
Yeah, exactly.
Okay, yeah, then that is some Europe thing today. Robert, maybe you want to first start with a short and brief description of what we are going to learn today before we start the presentation.
Yeah, sure. So front and center in this session is the Cloud Development Kit from AWS, or short for CDK. And that's a cool new way to program your infrastructure with real programming languages that makes it much easier to stand up complex architectures.
Okay, then I'm not going to take more of your time, so just share your screen and the stage is yours.
Awesome. Yeah, so I think we had a poll before starting with the presentation. So I'll be happy to look at that whenever we can. Oh yeah, that looks pretty nice. So actually quite a few different languages here up. That's pretty cool. The good news is, like, although this talk is about TypeScript specifically, all the languages I mentioned here are supported by CDK. So thanks for joining and being brave enough to show up if TypeScript is not your favorite language. So yeah, let's move on to the actual presentation. My name is Robert. I'm a solution architect at AWS. You can see my Twitter handle down here if you want to send me a message afterwards. And the topic of today is using CDK, the Cloud Development Kit, to program your infrastructure. So me personally, even before I worked at AWS, I already used the CDK, and I'm a super huge fan of it. In fact, I would say I might be even too big of a fan. So just as a disclaimer here, this will definitely be around like 30 minutes of me telling you how awesome CDK is. And at this point, I'm personally pretty religious about it. So for example, if a colleague comes up and says, hey, Robert, I have a nice new project. Do you want to join in? I'm doing something with AI/ML, something like that. I'm like, yeah, okay. Are you using CDK to set up your infrastructure? And they're like, no. Then I'm like, yeah, I don't think I have time for that. I have other stuff to do. So at this point, I can't really imagine my architect life without using CDK. And the way you can look at it, it's like, okay, this guy maybe has a slight problem. Or you could think, okay, he's like really convinced of this stuff. He really loves it. So it must be really good. And the goal of the talk in the end is that I can convince you of the latter. So let's dive right into what CDK actually is. And I have to read the formal definition out here because it's a quite lengthy one, but it's also very descriptive. So the AWS Cloud Development Kit is an open source, multi-language software development framework for modeling cloud infrastructure as reusable components. So what this means is that instead of using YAML or JSON to define our architecture, our infrastructure, we're using quote unquote real programming languages to do it. And you can see the ones that we support out of the box right here. So you can do it in Python, you can do it in JavaScript and TypeScript, you can do it in Java, in C#, and we also have a developer preview of Go. So that's all the languages you can use here. Now, the cool thing about using real languages is basically, I should stop saying real languages, but programming languages, is that if you are a developer, that's like super familiar for you, right? You're just writing code and you get cool features, cool supports from your IDE, like you get autocomplete, you get inline documentation as you write the code, and that's something you know very well. What you also get, and that's actually something that makes you super productive with CDK, is that it has a lot of abstraction built in. And we will see what that means in a minute. So you have these classes in CDK that actually under the hood do a lot of things for you when setting up the infrastructure. So there are a lot of like built-in sane defaults that you can reuse that make it much easier to get started. And finally, another cool thing is that CDK has some nice tricks about managing not only the definition of your infrastructure, but also managing the application code and even managing the CI/CD pipeline that deploys all this stuff together in basically one code base. And we will look at that as well. So now we know about some of the benefits. Let's dive into how CDK actually works. So you basically choose your favorite programming language, and then in that language, for example, TypeScript, you're writing a CDK application. And within that CDK application, you have at least one stack. And one stack is a set of infrastructure resources. So for example, if you are using AWS, it might be a serverless Lambda function or an S3 bucket and some more stuff. And you create these resources by instantiating these constructs. And constructs are these classes that actually represent a piece of infrastructure. Now, when you've done that, you are using the CDK CLI. The CDK CLI will run that code, and it will create a output in a configuration language. And in this case, for AWS, of course, that's the native cloud deployment language we have at AWS, which is CloudFormation. But it could be other things, and we will see that also in a minute. Now, then when you have this CloudFormation template, it is then deployed, and you can also do this through the CLI, and this is then handled by the cloud service of AWS CloudFormation, and the whole thing runs. Now, when I first looked at that, I was thinking like, yeah, okay, that's cool, but why do we need this like step in the middle? Like, can it just directly deploy to the cloud? Would be much easier, right? But the cool thing here is that basically CDK is not reinventing the wheel. It gives you that abstraction by writing code, but in the end, you get a CloudFormation template that is very well proven. It just works. It's declarative. And there's actually a lot of know-how out there on how to write CloudFormation templates. So if anything goes wrong, you can always look at the CloudFormation template, even fix it up or deploy it yourself, and it will work. So I think that's actually a pretty good balance that we are striking here. Now, we heard about, okay, coding with a real language, a real programming language, that's nice, but what are the real benefits? Like, how does it work when I actually do it? And so for me, I quickly want to tell you about my personal story of how I discovered the benefits of CDK. So a few years back, when I was transitioning into a new architect role, and that role was more focused on AWS service, I was basically challenging myself on creating a pretty simple architecture to figure out, okay, how complicated is it actually to use infrastructure as code with AWS. So I have this really simple infrastructure that you can see here. I just want a load balancer that is connected to the internet. And behind that load balancer, I have an EC2 autoscaling group, so a number of virtual machines that actually get traffic from the load balancer. And I was thinking, okay, that's pretty easy. Let's write that in CloudFormation and see how it works. And this is what came out of it. So in the end, I had a CloudFormation template. It's the native infrastructure definition that we have for AWS. It's fully declarative, so it does exactly what it says. I could use some snippets from the internet, and there are, of course, some add-ons for your IDE that can help you to fill this out. But in the end, I came out with over 300 lines of YAML that I had to write. And I was like, okay, that's quite a lot of stuff. Why is it actually so much? This looks like super simple. What's going on here? And the answer really is that when we zoom in here, this simple diagram, it's actually a lot of stuff. So you can see here, yeah, I need the load balancer for sure. I need my autoscaling group, but the autoscaling group needs additional configuration. And then I have all the networking that I have to set up, like my virtual network, the VPC, and the subnets, and the route tables, and the network access controllers, and the security groups, and the NAT gateways, and the elastic IPs. It's actually a lot of stuff you have to do here. And you actually are also spending some time, if you're new to AWS or to any platform that is using infrastructure as code like Kubernetes, you're actually using a lot of time to figure out what things do I have to instantiate, how do I reference them, how do I write the templates. So that's quite a challenge if you're starting out. Now, how does CDK pick up that challenge? So in CDK, we have this this topic of constructs. And constructs, as I already said, are classes, and those classes represent infrastructure. And these classes have different levels of sophistication, meaning different levels of how much stuff they do under the hood for you. Now, the easiest and simplest one is the level 1 construct. And that's basically just a one-to-one representation of the CloudFormation resource definition as a class in code. And these are automatically generated. So you can always do everything with CDK that you could also do with CloudFormation. The next level are those high-level service constructs. And these are still related to a specific service, like, for example, to my VPC or to my EC2 instance. But under the hood, they already do a lot of things for me. They wire up things, they set good defaults, and it really makes it easier for me to work with it. And we will see that just in a minute. Now, going even further, there are level 3 and higher constructs. And these constructs are pretty opinionated, and they can basically wrap complete architectures. Basically, my whole architecture that I showed you with a load balancer and the EC2 autoscaling group, that could be an abstraction that we could call simple load balanced web application. And actually, I can write these constructs myself and can share them with the public or within my company through GitHub or, for example, a package manager. So that's a way how you can actually build this up within your company and share these patterns that then other teams can use, which is pretty cool. So now I will quickly walk you through how exactly you are using CDK to create my simple web app architecture. And I could have done this like interactively, now that I think of it, but then you would have had to watch me fumble with my IDE, and you'd probably be like, oh, this guy is not writing 400 words per minute, so get out of here. He's not cool. So that's why you just get screenshots for today. So imagine here that I have used the CDK CLI to set up a skeleton app in TypeScript. That's something you can do with the CLI. And then I open my IDE. In this case, it's Visual Studio Code. And I start writing my CDK stack. So the first thing I do is I create a VPC. Almost every architecture at AWS starts with a VPC because you need a virtual private network where you put your stuff in. So I basically create this construct here. I instantiate it. And as I'm writing this already, I can see, wow, I get basically hints from my IDE on what properties I can set, and I get inline documentation, which is really nice. So I don't have to search for this separately on the internet. Now, if we zoom in a little bit more, we can see that, again, the magic of the construct is happening. So actually, this construct is doing a lot for me under the hood. So what we can read here is basically, it creates the VPC. It sets up a CIDR range, an IP address range for the VPC. It creates public and private subnets. It creates the network routing, creates the internet gateway. It creates NAT gateways, and it all somehow fiddles this together. If you're doing this on your own, that's actually a lot of work. But here we just wrote one line of code, and we're done with basic networking setup with sane defaults. So that's great. Now, the next step is to create this autoscaling group. So again, I use the autoscaling group construct, start to instantiate that. Here, I have to add some additional properties. So I pass the VPC that we just created. And now I need to define some extra things, like, for example, what instance type we want to use. And again, because it's code, you get typical things you do in code, like using an enum to actually define what instance type you want to use. You're not just writing some string that you have to remember and you probably mess up. No, you can basically use an existing enum that is provided by the library. Now, we do this a little bit more, for example, with the image we want to run on the virtual machines, and then we're basically done with the basic configuration. Now, we also want to run something on these virtual machines. So what we have to do here is we have to add some script that runs at the startup of the virtual machine to install a web server and maybe generate a dummy HTML page for us that we can open. So here we see a pretty cool feature again. First, there's a convenience function to do that. And secondly, we are referencing another file in our project that we're using here. So I have created a bash file that is basically doing some apt-get install Apache web server to go along. So that makes it really easy for me to basically import that and use it. With other configuration languages, you might have to basically inline this in your YAML or something like that. Here you can just treat it as a separate file and just read it here with a Node.js library for accessing files, and I can pass it to that function and I'm done. So that's already a glimpse into how CDK can help me to not only manage the infrastructure, but also the code that I'm writing. And basically now we're already at the last step. So we're creating the application load balancer. And for that, again, we are using convenience methods to basically set up that load balancer. So we call add listener to tell the load balancer to use the port 80 to be available on the internet. We add targets. So here we say the load balancer should please target the auto-scaling group that we created before. And last but not least, we're using this convenience function to set up the network security to actually not block incoming requests on port 80. And that's basically it. That's all we had to do. We have created the whole infrastructure. Now, if we compare that with the CloudFormation template that I did before, there are quite some differences. So in my CDK app, we saw that I used like additional abstraction through code with these constructs. We definitely saw that there are some imperative aspects, right? Because it's not just a declarative language. You are writing real code, so there is a code flow, and there is some state when we call these convenience functions. So definitely not fully declarative. There are imperative aspects. But on the flip side, we could use all these like built-in patterns and defaults from the constructs. And in total, we wrote less than 30 lines of code. So I guess in comparison, that's pretty good. And another thing I really like is, and that's personal, but I hope you agree, I think it's much easier to read in the sense of like a domain-specific language, right? I don't have to scroll up and down between hundreds of lines of YAML. I can kind of read this out aloud to understand what it does. And I think that's pretty cool for collaboration. Now we created that stack, and the next thing would be to basically use it in a CI/CD pipeline, or basically doing GitOps. And actually CDK can help us here. So typically, even in like modern environments, you could often find that these aspects of managing the infrastructure, managing the application code, source control, doing the actual configuration and deployment, these things still can be separated by tools and by responsibility. Now, what CDK tries to do here is basically bring all those things together so that I basically have one code repository, and in that one code repository, I can do all those things together. And if I change either the infrastructure or the application or the deployment process, either of these changes updates the whole pipeline, and I get that change live. And how CDK does that is actually with another construct, because of course, all the magic happens with constructs. So this is like a visual way of showing what we built here. So we wrote our CDK application before. We have created the stack. So here are the resources of my load balancer and my EC2 instances. And now what I can do is I can instantiate a new CDK construct called the pipeline, and I can put that stack in the pipeline. And then it would look something like this. So now we have the CDK pipeline construct. And in that pipeline construct, you can now, in TypeScript, define a source stage where you get your source code from a code repository. You define a build stage where you actually compile your app code. And then you actually define an app stage or deployment stage to deploy that stack into production. And of course, you could extend that stage with another stage for pre-production. And then you basically have a complete CI/CD pipeline. You have it in one repository. You have written the infrastructure and the CI/CD pipeline in one language, for example, in TypeScript, and it just works. So that's a pretty good way for like self-sufficient teams, small teams that build microservices, to basically keep control over the whole thing and be super flexible with their CI/CD pipeline. Oh yeah, and before I forget, there's actually a cool AWS online tech talk that goes deeper into that. You can find that on YouTube, just search it, and I definitely recommend if you want to go deeper into this. Now, up to this point, we've talked a lot about CDK as a tool by AWS for AWS. But CDK is definitely not limited to that. So in fact, a better way to think about CDK is to look at it as an open ecosystem for programming cloud infrastructure. And now I will explain what that actually means. So first of all, CDK is open source, so you can find it on GitHub. And you can also find the roadmap for CDK on GitHub. So there you can basically see what CDK is up to, and you can directly influence the development by upvoting issues. We also have a dedicated repository for requests for comments. So CDK is using a request for comments mechanism to improve and evolve. And that you can find in the AWS organization /AWS-CDK-RFCs. And there you can basically make your own proposals. You can comment on existing proposals and track when they're landing. And that's another way of how you can influence the development of CDK. Of course, I think I already mentioned that the construct library. So the construct we use, like the VPC construct, the autoscaling group construct, and so on. These constructs are also open source and are not just provided by AWS people, but actually we have hundreds of contributors who improve these constructs or even submit completely new ones. So whenever you're using a construct, you're really making use of the experience and know-how of many hundreds of people that are building infrastructure on AWS. And if you would like to know how to contribute to this library, there's actually a talk from re:Invent 2019 that goes deeper into that. Now, so far we have talked about the community, but we still haven't touched on if I can use CDK when I'm not actually running stuff on AWS. So this construct programming model that we've talked about a lot, which means you create those constructs, those classes of code, and then they are transformed into configuration artifacts. That basically works for any kind of configuration language as an output. And the cool thing is that actually quite a few open source tools already adopted that model for their tooling. So let's check out some examples of how that could look like. One very prominent example here is definitely the CDK for Terraform. So it basically says exactly what's on the cover. It's CDK for Terraform. So again, you write your infrastructure as code, and then the CDK TF CLI, so basically a sister of the CDK CLI, then transforms that into a Terraform JSON configuration. And that's a perfectly normal Terraform deployment configuration. You could just take it and deploy it like normally with Terraform, or you can do it through the CLI. So with that library and with that tool, you basically have all the things available that Terraform offers you to define infrastructure. And now you can do it with programming languages as well. For that, there's also a deep dive from HashiCorp. So you can find that on the internet to check out how to use CDK for Terraform. Now, another cool tool is the CDK for Kubernetes, or CDKs, as they call it. So again, pretty much the same setup. You write your Kubernetes deployment configuration in code. And then the CLI turns that into a Kubernetes YAML configuration. And it basically supports like all the features that you expect from Kubernetes for deployment. And again, there's a deep dive actually from last reInvent where you can see how this works in detail. What's really cool about this is you can basically use this with any Kubernetes cluster. It doesn't matter on which cloud it is deployed, but if you happen to do it on AWS and you're using the managed Kubernetes service from AWS, which is called EKS, you can actually combine the CDK for AWS and the CDK for Kubernetes. So you can not only write as code the creation of the Kubernetes cluster, the EKS cluster, but then you can also write the deployment specification for your apps, and you can pass that to the CDK for AWS. So again, you have this idea of unifying things, of bringing them together. And here you can definitely see how this works for first creating the platform, my Kubernetes cluster in AWS, and then also creating the actual app deployment configurations in Kubernetes, all in one go. And that's also shown in this deep dive, so definitely recommend that if you're interested in it. Now, we've seen that we have this like ecosystem of libraries that kind of adopt the CDK way of implementing infrastructure or deploying infrastructure. And with that, also the community is growing. So here are a few examples of how the community contributes to CDK. The most prominent thing is definitely the CDK Day. That was just on the 30th. You can find the recordings on YouTube as well. And on the CDK Day, it's basically all things CDK. It's, again, not just CDK for AWS, but definitely CDK for Terraform, CDK for Kubernetes, and other tools in that space. It's a really cool community gathering where the brightest people come together and just do very cool things with CDK. I definitely recommend to check that out. There's also, even if you're not super interested in CDK at this point, and I hope you are, it's even just worth to check it out because there's like a live like sign language translation happening, and I'm like, whenever I look at that, I'm like super baffled on how you can do that for the technical language that we're talking there. So alone for this part, I definitely recommend you to check it out. It's amazing. There's, of course, also other like community websites and forums to support you with your CDK journey. So one of them to call out is definitely cdkpatterns.com. So that's also a community curated website of constructs that are provided by the community. And if you go to their Twitter and follow them, you can also get additional news about CDK, which is pretty cool. And of course, last but not least, we also have an awesome CDK list, which you get for basically everything. Here's the link to GitHub, and there you can find many more open source projects, guides, blogs, and resources. Speaking of resources, I'm almost done with my presentation here. I would like to leave you with this slide. So here are some quick start resources for you to get started with CDK. If you want to do it the TypeScript way, all you have to do is install Node.js, have the AWS CLI, log into an AWS account. Then with a Node package manager, you install the CDK CLI, and then you can use this call here to initialize a skeleton app in TypeScript. And then you could basically follow my example that I showed here in the slides to get going. If you want a more guided experience, you should definitely check out the cdkworkshop.com website. You can also choose between different languages there, and it's basically a guided example of creating a CDK app. And of course, as always, we have quite a few samples under the AWS samples path at GitHub. And to round it up here, that's again the list of different talks and resources I mentioned here. Definitely check those out as well. So that's pretty much it from my point of view. I hope I have you convinced that I'm not crazy, I'm not a maniac. It's a really cool tool. And I hope that you are interested in picking this up. And I hope someday you can tell me about how you have basically wowed your colleagues with like a very cool construct, really cool setup in CDK. So definitely looking forward to that. Yeah, and I guess with that, I'm looking forward to any questions.
Thank you, Robert. That was a very interesting presentation. We can really feel that you love working with CDK. Yeah, there is actually two questions only. We have one question is, can you create resources without interfering the development environment?
Trying to interpret that question. So I try to answer it like this, and please, from the audience, add a question if you're asking for something else. With CDK, you can define, for example, in which account you create that stack. So you could have one account for developers where you create this stack, and then later you also deploy it on a production account. And if you remember the pipelines, the CDK pipelines I showed, actually these pipelines support that. So you can say, hey, first stage deploy to account developer, second stage deploy to account production. So yes, you can definitely cleanly isolate your deployments with CDK.
Okay, I hope this answers the question. The next one is, what are the current limitations of CDKs? Or let's say, what can't you do with it?
I told you, I'm not talking about limitations. It's all great stuff, right? No, but seriously, I think to basically to best describe the let's say limitations or challenges of CDK is it's the challenges you have with every abstraction, right? An abstraction is great when it works, and if it breaks and you have to go down that rabbit hole and figure out why it's not working, then you hate it. I think this is the major concern here, and I think to somehow mitigate that concern, if you remember, I talked about how in the end you always get a configuration template in a well-known language like your Kubernetes YAML files or your CloudFormation template. I think that really helps to basically fix it up or to understand what's happening. So that's a good balance.
Okay, and then there's a question from Felix. Thank you, Felix. Would you recommend to keep the synthesized CloudFormation templates around, or do you consider them as ephemeral artifacts?
Oh, wow. Very good question. Also, shout out to Felix. Cool that you're here. Yeah, so that's a super interesting question. So I think the official way is that these are like built compile outputs that you typically do not store in your Git repository. You put them on git ignore, and I think that's also when you create a skeleton app with CDK, it actually ignores those files, so they will not be saved. I think there are definitely reasons why you would like to save them. For example, a thing you could do just for sanity check is if you keep the latest few versions of that template, you can basically, before you do a deploy, you can basically do a diff and just see how did the latest compilation maybe change something in your quote unquote compiled code. to see what differences are there. So I guess for reasons of being super safe and trying to understand what CDK does under the hood, it could be helpful to store these templates, but it's not a must.
Okay, Felix, I hope this answers your question. If you have another question, just go for it. Otherwise, we are basically, finishing with this session, but maybe Robert, there is something that you still want to mention. What does the future bring? What are you looking forward to? What's the next steps?
Yeah, absolutely. So I think for the future, one interesting thing that I haven't talked about is that we are just starting to release CDK version 2. And that's basically an upgraded version of CDK, which is streamlined in some aspects and also makes it even easier to work with CDK. So in the past, right now, if you use CDK, you are basically importing libraries for like each construct. You have to import a lot of libraries. You have to see that their dependencies and versions work correctly together. And with CDK v2, you don't need that anymore. You get basically one monolithic library, which sounds bad, but actually for you as a developer, it's good because everything works together in that library. Basically, to finish off here, maybe one additional advice I would give you. So one big mistake I did with CDK, and I want to make sure you're not doing it. If you remember my example, and I basically created that architecture in CDK, deployed it, and then I basically stood up, went outside of my office, went to my wife and said, wow, that's awesome. Like I did so much stuff today in so little time. It's absolutely amazing. And she basically said, well, honey, that's super cool. So you have some time for the dishes, right? Yeah. So definitely don't do that. Keep your enthusiasm to yourself, but surprise your colleagues with CDK. And I'm happy to hear what you are building with it.
Okay, but there is worse things than doing the dishes, right?
Yeah,
we
I
should be
think so.
supportive to our wives, right?
Definitely.
Okay, good. Robert, it was a pleasure having you today. I hope to have you also at the Congress in the future. But do you still want to share maybe your Twitter handle or something where people can follow you?
Oh yeah, so it's Rob Hoff Max, so ROBHOFFMAX, and yeah, would be super happy if you're trying out CDK, what you achieve or what you're not achieving, drop me a line. I'm super happy to know about it.
Okay, so you heard it all. If you are interested in CDKs, then Rob is your guy. We are going in a short break again, and we will be back in 18 minutes at sharp 4 p.m. with our next talk. Another Rob Richardson this time, database DevOps with containers. So see you in a couple of minutes.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you.
Welcome back, everyone. I am here with Rob. You know Rob from one of our past live sessions, and as we got really amazing feedback about his talk, we just decided to invite him again, but this time with a different topic. So he will talk about database DevOps with containers. Rob, welcome. Greetings to Arizona. And how is life doing?
It's doing really well. It's a bright, beautiful morning here in Arizona this morning.
That's good. Do you want to give a short introduction before we start the session? What will you talk about?
Yeah, definitely. This talk is really, really fun because usually when we talk about DevOps pipelines, we talk about building them for applications. And in this case, we're going to talk about building one for a database. And one of the interesting things is that we'll look at, well, how do we build a DevOps pipeline for databases? Where do we start? So this talk will focus on getting production data into non-production environments safely. And that's really scary. It's like, well, I've got secrets and I've got user information. How do I anonymize, sanitize, and shrink that data to make it appropriate for other environments? And that's where we'll focus, is making sure that we can move our data safely from production to non-production environments. We'll also get to see how we can build stateful containers, because Docker is a really elegant mechanism for deploying content like this to non-production environments. Once I bake the content into the container, then if I want to reset my dev environment, I just turn it off and start it back up again. It's going to be so much fun. Join us for this adventure.
Okay, Rob, the stage is already yours, but now you can also share your screen and we can kick off the session.
Welcome, everyone. Database DevOps with containers. This is such a fun journey. Here's the part where I tell you I am definitely going to post the slides on my site tonight. They are online already. I've been that guy chasing the speaker as well. It never works out when we say, I'm definitely going to post the slides tonight. So you can head over to robrich.org right now. Let's do that. Let's head over to robrich.org. We'll click on presentations, and here's Database DevOps with containers. Not only do we have the slides online, but we also have the code here online up on GitHub, and it is there right now. While you're here at robrich.org, click on About Me, and you'll see some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate, a single store developer evangelist, and let me tell you about AZ Give Camp. AZ Give Camp brings volunteer developers together with charities who otherwise couldn't build software. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software to the charity. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp, or if you'd like a Give Camp here or wherever you're connecting from, hit me up on email or Twitter, and let's get a Give Camp installed in your neighborhood too. Some of the other things that I've done, SQL Source Control Basics, that was a lot of fun. Mine's chapter 8. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air. They sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into database DevOps with containers. We talked about this guy. When we're looking at database DevOps, or when we're looking at DevOps as a whole, our goal is to do things in a very automated and consistent way. Reliability, consistency, and cost. Well, cost is an interesting thing. It used to be that it was cheaper for us to poke at all the buttons again. I remember stories of people reading through their punch card decks before submitting them into the computer in case there was one out of order or in case they had typoed something, just to make sure that they weren't wasting that really expensive compute time. But, well, computers are now a lot cheaper than people. And so I can run all of the tests on my build server and get a feel for how those work. And that's cheaper than paying the person to go push all the buttons. Reliability, consistency, and cost. Our goal with DevOps is to automate all of the things. As database experts, I'd really like to sleep through that thing rather than having to wake up and get the database going again. So let's take a look at a DevOps pipeline. As we look at a DevOps pipeline, let's first start with a DevOps pipeline for applications. Now notice in this DevOps pipeline, we start with a user suggestion on the left, and we end with user feedback on the right. A user suggestion and user feedback. We have customers at both ends of our DevOps pipeline. If your DevOps pipeline doesn't start and end with customers, I would invite you to add them to your DevOps pipeline. Our goal as software developers is to deliver value to users. So let's make users a focus of delivering that value. In this DevOps pipeline, we start with a user suggestion that will go up on a task tracking system. A developer pulls down a task, starts encoding the content, and ultimately commits that code to a source control system. The build server will notice that that code has been committed and will start off doing the build. It may run some automated tests as part of that build and ultimately deploy that to a non-production environment. Now, at that point, maybe there's more users poking at it, or maybe we're doing more invasive automated tests. Once that build is good, then we'll deploy it to a production environment where users can start to experience that feature and give us feedback. That's a DevOps pipeline for applications. And the beauty here is if any of these pieces fail, we can stop that pipeline at that point, and we can use that feedback to correct actions. Now, in this case, a unit test failed. Maybe that doesn't go all the way back to user suggestions. Maybe it just goes to feedback to a developer. But now we won't do those other steps, deploying to non-production or production environments. We can begin again and make a more high-quality product. As we talk about shifting left, our goal is to get feedback faster. Can we do this in, say, the developer's IDE so that the developer doesn't even need to commit the code to get that feedback that this test will fail? That's really interesting. So we have this DevOps pipeline. Where's the master copy? If we were to lose everything else in this diagram, where would we begin? Well, in this case, the master copy is our source control system. When we have a source control system, we can begin there and we can do all the things. Our build server can kick off and run our build, validate all the content through all the tests. We can deploy it to a pre-production environment and do more invasive tests, and then we can deploy it to production. If we lose our source code, we're stuck. Well, that's great for applications. Let's now flip this on its head. What about for databases? Where's the master copy? Is it our source control system? Well, probably in our source control system, we're storing schema. We're storing table definitions and store procedure definitions and user-defined functions. We might be storing lookup data, static data, enumerations. But that's not really the master copy. The master copy is here in production. Here in production is the user's data. If we lose that, we lost. Users don't really like it if we deploy a new version by deleting all of their data first. Our production database really is the master copy. Now, the cool part here is let's begin there and create a DevOps pipeline that can get this production data into non-production environments. Now, we might have a similar DevOps pipeline that will get the schema changes into each environment. And so we'll have a mechanism where we check out those schema changes and we build them, we validate that they work correctly, and we end up deploying those migrations through to production. This isn't that DevOps pipeline. This is the DevOps pipeline of taking that production data and making it available for non-production environments. Let's zoom in a little bit and take a look at this mechanism. Now, we do want to have a DevOps pipeline that starts and ends with customers. But in this case, we're going to zoom in and focus in on the developer, the pre-production environments, maybe a dev test environment, and finally production. So let's start with this DevOps pipeline. We start with a production database, we back it up, and we restore it. This might be a disaster recovery plan. Now, in this case, if we have an automated DevOps pipeline that is able to do this backup mechanism, and another task that is able to do the restore, then we can do that automatically if we have that need. Now, maybe the restore needs to be more fine-grained. Maybe we're only restoring a single table, or maybe only even a single row. So maybe it doesn't automatically go back in, but that backup process should be automatic. Taking that a step further, what if we have a pre-production environment? Now, in this case, we'll need to back up our production environment, and we'll need to restore it to a pre-production environment. Well, the pre-production environment may not have the same hardware in place. Maybe it's, well, connecting to different data stores. We'll need to do a process of anonymizing, sanitizing, and shrinking this database appropriate for this environment. As we move down the list in dev test, well, here on the build server, we definitely don't want to connect to production databases, and we'll probably want to anonymize some data. Well, we want to protect users' privacy, but also if we're testing the email functionality, we don't want those emails to go out to real users. So we'll want to anonymize that data as well. We'll want to sanitize the data, remove any production secrets, remove any connection details to live APIs, and allow this database to be used for doing our builds or our dev or test environments. As we get to a developer workstation, then our needs are a lot more constrained. We have much more constrained hardware. We have much more rigorous details around security and privacy. So we'll definitely want to anonymize, sanitize, and shrink this data appropriate for a development environment. Now, developers are really good at accidentally forgetting the where clauses. And so we want to create this mechanism where we can do this process automatically and not need to focus in on, let me drop everything and create a mechanism for you to get your database back up to speed. At each of these levels, we did this process of anonymizing, sanitizing, and shrinking the data source appropriate for that environment. When we anonymize, we'll change user data so that we can protect privacy or HIPAA compliance or PCI compliance. We'll change things so that we don't accidentally email users by changing their email address in the database. Sanitize. Let's clean out some production secrets. Let's make sure that we change API keys and other secrets so that those don't leak outside the production environment. And then shrink. Now, when we shrink the database, our goal is to delete bulk in the database so that we'll have a smaller data set. But our goal is not to clean up the data. We're not going to delete everything older than 6 months or older than a year, but we can delete maybe the second biggest account, or maybe accounts 6 through 10 in the size thing. We do want to leave the biggest account so that the queries that are weird or slow when you hit a big account still happen here. But maybe we can truncate some of the orders that are really stale, or some of the bigger accounts, or truncate some logs. Our goal is not to change the shape of the data, but rather to remove the size of the database, some of that bulk. We do want the data to be as weird as it is in production. Did this foreign key happen to get into place and not actually point at a real record? Did a field happen to get to be null, even though we didn't think it should be? Let's leave these in place so that developers' code can handle that correctly. And then ultimately, once we've anonymized, sanitized, and shrunk this database appropriate for each environment, as we restore it into place, let's run those migration scripts that get it up to the current version appropriate for that environment, and then validate that the system works correctly there. Now, the beautiful thing is when we go to deploy to production, we'll run those migration scripts. Here, we're running them in pre-production environments every time we restore a production database. So basically, we're practicing our production deployment when we do any of this work. That's wonderful. By the time we actually deploy these migration scripts into production, we validated that it works in a couple of environments. We know that this will go well. Our goal to automate all the things. We want to do this process of anonymizing, sanitizing, and shrinking appropriate for each environment, and we want it to happen automatically. Let's kick off these builds as soon as the production backup finishes. Grant Fitchie likes to talk about how our production backup is only as good as the last time we restored it. Let's restore it every day. Now we validated that the production backup worked. Hey, that's cool. So how can we automate this? Let's automate this with containers. So containers. Now, in the application development world, containers are just part of what we do now. Inside the database world, maybe not so much. So this is definitely not a talk on Docker, but let's take a look at some of the key benefits of what Docker can bring us. Docker, how is this better than Puppet or Chef or virtual machines? How do we build them in an automated way? Isn't Docker just like VM++? Well, kind of, but kind of not. Docker is an ecosystem around container virtualization. Let's double click into that. What are containers? Containers will virtualize the operating system, the kernel, where virtual machines will virtualize the hardware. Because we're virtualizing the operating system, then we only need those pieces inside the container to launch our specific application. We don't need a whole operating system. So then what is Docker? It's this ecosystem to help us build and run and monitor and restart these containers in a really elegant way. Docker didn't create C groups and namespaces and jails. Docker just made it really easy. Much like the difference between XML HTTP request and AJAX. What's the difference between XML HTTP request and AJAX? Well, nothing. It's exactly the same thing. Well, kind of. The way we do AJAX is with XML HTTP request. But XML HTTP request was this thing to power the right-click menu in Outlook in the 90s. AJAX is a mechanism to build Facebook and Google Maps, and that application that you'll facilitate tomorrow. Docker didn't invent containers, but Docker made it easy for all of us to use them, to consume them, and to work with them. That's wonderful. Here on the left, we have a typical virtual machine environment, and on the right, we have containers. We can see on the left that we have lots of copies of this operating system. So if we need another container, or if we need another virtual machine, we can clone it, but we still have a copy of that operating system. By comparison, here on the right, we have the operating system just in one place. That's the piece that we're virtualizing. We have a hypervisor, same as we had over here, and we have all of our containers. We can see that straight away, we're using our hardware more efficiently. Now, this is definitely not to scale. Hopefully, you can get more than 3 virtual machines on one server, but we see that we use the hardware much more efficiently because we don't need redundant copies of that operating system. Containers let us use the hardware more efficiently. Now, because containers are using the same kernel as the host operating system, because they're sharing that operating system, then our containers need to be the same kernel as the host. So Linux containers run on a Linux host, and Windows containers run on a Windows Server host. Well, what's missing here? Well, how about GNOME and KDE? How about Red Hat and Ubuntu? Can I run a Red Hat container on an Ubuntu host? Well, what are we virtualizing? We're virtualizing the kernel. And in this case, it's the Linux kernel. The Linux kernel is that same kernel underneath Red Hat and Ubuntu. So yes, I can put an Ubuntu guest on a Red Hat host or a Red Hat guest on an Ubuntu host. All of the Red Hat bits in that Red Hat container are inside the container. We're virtualizing the kernel. What else is missing? Well, how about Mac and Windows Desktop? If we're doing development, we'll do it like this here on the left. In production, we want to do it here on the right. We want to use our hardware as efficiently as possible. But here on the left, we may choose to do it in development like this. So I have my Windows laptop. I have my Windows. I have Hyper-V. In the case of Mac, it's HyperKit. And then I'll use this small Linux virtual machine. Now, inside the Linux virtual machine, I'll install the Docker hypervisor, and then I'll be able to run my Linux containers inside my Linux virtual machine running on my Windows desktop. Now, if we're using WSL2, then this can be WSL2, Windows Subsystem for Linux. And so we can then just install Docker Desktop there and run our containers inside WSL. That's really cool. Now, because we have a regular hypervisor, we can install other guest OSs as well. And that works out well too. The Docker ecosystem. Now, the cool thing about Docker is that it allows us to get from configuration as code to running containers really easily. We'll start out with this Docker file. Now, this Docker file is configuration as code. It's a text file that's, I don't know, a few K, 20, 30, 50 lines of text. That configuration as code is all of the steps that we need to be able to build an image. So we start with the Docker file and we build an image. Now, this image is not that running container, but it is a binary blob that represents all of that built content. We could think of this like source code. This is maybe that built object, and this is an instance of that object. Now, the cool part about this image, I could share that with Docker Hub. I could pull down images from Docker Hub. We're sharing the binary blob. We're not sharing the source code. That means that if I pull down an image, I don't need to recompile it. I just need to start it. And then when I'm ready, I run that image as a container on a Docker hypervisor or any other container runtime. Now, these are OSI compliant containers, and so I can run them on Kubernetes or anywhere else that OSI compliant containers can run. The Docker hypervisor, in this case, plugs in Ethernet and power and boots up that container. Perfect. Now, I can run many containers. Maybe I have a Docker Compose file, or maybe I have Kubernetes YAML files that will specify many images. Maybe they're built from Docker files, maybe they're pulled from Docker Hub, and they're all started together on the Docker hypervisor or inside Kubernetes so that we can monitor and scale those together. So that's that ecosystem. We start out with a Docker file, we will build up an image, and we'll run a container. Here's an example of a Docker file. Now, in this case, this Docker file is building an ASP.NET website. We have some instructions here that identify the steps that we need to take to build up this image. We're going to copy some content from our local machine. We'll run some shell commands. We'll copy some more content, run some more shell commands. We have pretty much 4 standard Docker commands that allow us to do interesting things. From, copy, run, and CMD. And you see there are a few more, but with those 4 commands, from, run, copy, and CMD, you can read pretty much any Docker file. From identifies the base image that we're going to start with. Let's stand on the shoulders of giants. And then CMD is that command that we will run to start up the container. Now, in this case, we're going to start up the .NET site, but we could choose to start up any process. All of these tasks happen at build time when we're doing the Docker build, and this last task happens when we start the container. Now, this is an example Docker file, and we can dig into the particulars here, but our developers are already using Docker files like this to run their applications. So when we look at that mechanism, we looked at this base image. Let's head over to Docker Hub, hub.docker.com. And I will type in .NET. Let's go to the .NET repository. I will come here into the ASP.NET container that we used. Now, as I cruise through here, I see various labels. Now, in this case, we use the latest label. So let's dig into the Docker file that built that. Now, our Docker file rests on top of this Docker file. We can see that it's doing some curl content. It's setting some environment variables. And this one's based on this image. Okay, let's head back over to the .NET runtime. Here is the runtime, and we can take a look at the images associated with it. Here's the Docker file that built that image. Now, each of these steps will create a layer inside our Docker image. And once we've created that layer, then we have that ephemeral layer. It won't change. But we can see that it builds up. This one starts then from runtime depths. And so we could walk through all of those pieces until we got to scratch. Now that's that beginning spot. We can see that it is, well, turtles all the way down. Here's our layer, and it's on top of this layer and on top of this layer. But once we have this layer on disk, we don't need to grab it again. Here's each of those commands in our Docker file. Each of them will build up a new layer, and that's based on top of this image that has these layers and this image that has these layers. Then once we start this image as a container, we get a new read-write layer specific to each container. Now, the cool part here is that each instance of the image, each container, will get its own read-write layer. So now we can do things like storing logs and all of the content. Turns out that operating systems don't really like running in read-only mode. But then once we kill off that container, that read-write layer is gone, and all of this content stays. Did your container get hacked? Did the system try to delete or replace runtime dependencies? All of those just happened in this read-write layer. And the moment that we stop this container is the moment that that read-write layer just disappears. That's perfect. So Docker, it spun up the hardware really fast. We still have a unique host name and IP. We still have that great sandboxing mechanism that we had in virtual machines. And we can NAT traffic from the host into the containers. What's wonderful here is that this Docker ecosystem allows both dev and ops to work with the same content. Developers treat the content as the inside the container, where they can arrange the content just so. And operations can work outside the container, where they just stack it up into great places. Inside the container, we can pretend that it's a machine, where outside the container, we can pretend it's a process. Plug in Ethernet, plug in power, and just start it up. So here on Docker Hub, we had ASP.NET, we had Node, PHP, Ruby, Go. But on Docker Hub, we also have databases like Redis, PHPMyAdmin, WordPress, Postgres, and SQL Server. Let's double click into SQL Server and take a look at that content. Here on Docker Hub, we have SQL Server. Now that's perfect. It moved. We have an instance of SQL Server running inside of Linux that we can use just like we used SQL Server running on Windows. So SQL Server running inside Linux works out really well. We have all of the features that we expect from SQL Server. Now, if we're running a database in production, we should run a database as a service mechanism. Let them worry about point-in-time restore. Let them worry about backups and user authentication and access. Let them worry about uptime. We want to focus on our business application. If we're on-prem, then we're probably using virtual machines. Remember how we used to say, don't run a database inside of a virtual machine, only run it on bare metal? Now we run them inside virtual machines. The same will come in time where we'll start to run our databases inside containers in production as well. That may not be today, but 4 years ago, we said we would never run databases in virtual machines either. The day will come when we run in production in containers too. In dev test, we have a lot different needs for our databases. It doesn't matter that they're not durable. It doesn't matter that they may come and go. What we want is a dev-friendly mechanism that can run last night's production backup, but anonymized, sanitized, and shrunk appropriate for this environment. And we want that to be automated so that we can sleep as developers burn down their environment. So let's take a look at a mechanism of doing this inside of SQL Server. Here I have a database where I've just grabbed some customer data. Let's take a look at this customer data. Now this is random data. Thank you to randomuser.me for this. These aren't actually real people, but we can see that we've got email addresses. We've got usernames, first and last names. Taking a look at the invoice log, In this case, we have a bunch of invoices and the dates that they have. We might have other information like links to customers and products. And then we have some details, some settings. Now, these production secrets, we definitely don't want to leak into non-production environments. I also created another one, the build date, just so that we can see when we did this process. So we're going to want to anonymize, sanitize, and shrink this data. We're going to want to anonymize these email addresses so that we don't accidentally email real customers from non-production environments. We're going to want to shrink our database to remove some of the invoices that maybe don't make sense. Now, we're not going to want to delete a lot because we don't want to change the shape of the data, but let's delete maybe the biggest customers 6 through 10 so that we remove a lot of weight from the database, but not change the shape of the database. And then we'll want to sanitize the data. Let's remove production secrets. Okay, so here in our source code, we have up on GitHub this database folder. Now we have other details associated with it. Here's this backup production script. Oh, let's actually do that. Let's back up production. Okay, so let's back up production here. And we just backed it up right now. Now let's dig into this database folder where we have this Docker file and this SQL script. Here's this SQL script, and we can look through this mechanism of how to anonymize, sanitize, and shrink our data specifically to get from production to a developer's workstation. We might have a different script to get from production to a dev test environment and to get from production to a pre-production environment. In this case, we're going to restore our database. Then let's sanitize the data. We'll set our email address to something random. We'll sanitize our data. We'll set our secret to a dev safe secret. And we'll shrink our data. We'll delete invoices. And in this case, where 1 equals 0. So we're not going to delete any invoices at all. But let's also update that build date so we know when the database was built, just so that we can see this in the demo. Now let's do that process of shrinking the database. We're going to set the recovery mode to simple. We'll shrink the file. We'll shrink the other file. Now we have a smaller file. But, and let's also change the SA password in case the developer needs to be able to do SA work as well. Now we'll use this inside this Docker file. Now this Docker file will start with SQL Server 2019. We'll accept the EULA and set the password. We could pass this in as an argument. In this case, I just set it as an environment variable. And then we'll copy our production database and copy this script. Now we might choose to use volumes for this, but in this case, it was kind of easy to just copy it into place. Now we're going to start up SQL Server and wait for it to start up. I wish there was a mechanism where this would return as soon as SQL Server was running, rather than as soon as it had kicked off the process. So let's guess that it'll take about 80 seconds. Then let's run this command where we're running that process of the prod to dev.sql, this SQL file we just looked at. And then once that finishes, we will kill SQL Server. Now, the beauty of the Linux container is it will trap this kill signal and it will finish up the transaction and close the database safely. That's cool. We won't have any partial transactions. But we know that this process finished by the time it went to go run this process. So we know we'll be safe. Now, each of these commands is a new layer in our image. And so, well, once we run this process, we still have the production database backup in there. We don't want to publish that because, well, the non-anonymized, sanitized, and shrink data is still there. So let's create a new image, a multi-stage build that allows us to start over. We're going to start with SQL Server 2019. We'll accept the EULA just so they don't have to pass that on the command line. The SA password is already set. We set that inside the script to a safe password. And then let's copy all of the data stores from that, from the spot where they were in this image to this image. We'll copy from equals build. We tag this one as build. Now we are going to chown them to the correct user because this container doesn't run as root. That's a good thing. So let's do this. Let's do this process. We're here in this directory with the database backup that we just built right now. And these two scripts, docker build-t dev-database dot. Now we can see that I have run this previously, so we are using some cache layers. But as soon as we copy our production database into place, we've invalidated this layer. And so from here on, we're doing new content. Maybe in our automated build, we want to specifically not use cache to ensure that we don't accidentally reuse previous things. Now here's SQL Server starting up. And I love this because we'll see that in short order, it's actually going to do some upgrades. I'm using SQL Server 2017 on my local machine and 2019 here in the container. So there was that update. That's cool. Here it's updating from 897 to 904. Very nice. And guessing how long this will take to start up, we now see our database ready to go. Pretty soon, we'll run that script that will anonymize, sanitize, and shrink our database specific for this environment. Let's anonymize it by changing the email addresses. Maybe we need to change other data, PCI data or PII data. Make sure our data is HIPAA compliant as it leaves a production environment. We may want to generate random data in some places to protect users' privacy. We'll sanitize it by changing our production secrets. In this case, we changed it to a dev safe secret and we changed that build date. And then we'll also shrink it so that we can get it specific and valuable for this environment. There, we did that process. We updated our database. We're running these scripts. And now we are copying it into our new container. And we've got that image ready to go. Docker image list. We can see that this image, this latest one, it was built right now. That's perfect. We now have a dev safe database run in this, baked into this image. Let's do a Docker run -p 1433 to 1433. We'll say dev database. And let's launch this into place. Now, if we had something else running on 1433, we could definitely change this to, I don't know, 14330 or 1434. But we've got this database running now in our developer environment. So let's connect to it. We're here in SQL Server, and let's run this connect process, and let's connect to this database. Now, in this case, I'm running it inside of Minikube rather than Docker Desktop. So I'll connect to it with the server name Minikube instead of localhost. Now that we're connected to this database, let's create a new query here. We can see that this database is the exact same database that we had before. That's perfect. And now let's go run those queries. Let me go grab those 3 queries. Let's use our new database, and we'll select everything from customer. We can see that we anonymized our email addresses. We won't accidentally email real customers because we've changed these to fake email addresses. Now, we may want to randomize our other data as well. We can see that we have the invoice logs, and we've truncated this to match as we expect, where 1 equals 0. And our settings, we see that we have our dev safe API key here. So we're not leaking production secrets, and we can see that it was run right now. This is UTC. That's perfect. Now, if a developer does something silly like forgetting the where clause, they can say Docker compose down, Docker compose up, and reset their database. Whenever they're ready, they can Docker pull and grab the latest copy of the database. Now, what we need to rig up through Jenkins or GitHub Actions or Azure DevOps is that mechanism of kicking off this Docker build process, probably pushing it to a local container registry as part of that process every night. As soon as our production backup finishes, we can kick off the build specific to developers, to pre-production environments, and to dev test environments, launching the scripts that are specific to those environments. Now, this was really cool. We got to see how we were able to build a DevOps pipeline for SQL Server to get production data into non-production data environments really safely. Now, what's really cool here is that we didn't need to do a whole lot of installing of SQL Server. If you ever walk that through with someone, no, don't push that button. No, down, up. Yeah, that one. All of that is done for us as part of containers. Now, the SQL Server container has all of the features of regular SQL Server running on Windows. And we saw that, well, that Windows backup restored on Linux just fine. We also have the SQL Server agent, including SQL CLR. If you're using SQL CLR, you can run that inside of SQL Server running on Linux. That's amazing. Machine learning and agent-based replication, I believe those are already now in place. There are some features that aren't available on SQL Server on Linux, like reporting services and analysis services, those things that require Active Directory or IIS. They just don't make sense on Linux. But we saw that we could take this really easy mechanism of just restoring our production backup, running this script, and getting it in place. At this point, it's automatic. Our developers don't need to futz with it. DBAs don't need to futz with it. It just works. I would invite you to clone this repository and create a similar mechanism for building a DevOps pipeline to get your production data into non-production environments safely. Anonymized, sanitized, and shrunk, specific for that environment. If you're watching this video later, hit me up on email or on Twitter and let's continue this discussion. For those people who are here live in the conference, what are your questions?
Thank you, Rob. Very nice presentation with a lot of energy, just as always, right? So
thank you.
Let's see if we have some questions. So there's one thank you from Kurt. He's saying amazing talk, thanks. Then we have one question. Do you have any security concerns using this approach?
Yes, as our schema evolves, we may notice that some fields aren't protected correctly. We will need to keep up our script to match the anonymized, sanitized, and shrunk needs that we have. Towards security concerns, yeah, we are taking production and data and putting it in non-production environments, especially if we allow developers to pull this to their local machine. Make sure that you anonymize and sanitize and shrink it enough that there really isn't any big concern with theft or loss. Now, that is a tall ask. What you may determine is that, well, we really can't afford to get this outside of our VPN. So maybe the environment is only available inside the VPN and they can't actually pull the container to their local machine. Or maybe you'll have a whole bunch of warm spares spun up and they just connect to it. They don't even pull the containers. It is possible to create security holes in any system, and this is no exception. But ultimately, I think if you can keep your script up to date to anonymize, sanitize, and shrink your data to remove those concerns, then for the most part, you've protected that security concern.
Okay, thanks for that answer. Another question. How did you get the idea to explore database DevOps? What went wrong?
Yes, good call. The developer who said, hey, I just burned down my database. Can you help me restore a new copy? And the DBA is like, no, I don't have time for a couple of days. And so the developer is just sitting there twiddling their thumbs saying, well, I can't work. I don't have a database. And the DBA says, well, your emergency is not my fault. So that dynamic led me to go explore new opportunities. And at that point, I found this database DevOps mechanism, and I'm like, yes, that. Okay. If you're in a very regulated environment, maybe this approach isn't a great fit for you. But for those places where you're a little bit freer with your data, it can be a really elegant solution to be able to get non-production data in a very automated way.
Okay, and then there is one question. I'm not sure to what it's related, but it's actually, what would you wish to be easier?
What would I wish to be easier? As you start up the container the first time, it needs to copy the file to the top layer. If your database is a few megs, this doesn't take very long at all. If it's a few gigs, your database may be unavailable for, I don't know, a few seconds, maybe 10 seconds. And I wish that was easier. I wish when you started the container up the first time, it just ran smoothly.
Okay, Good. That was the last question, actually. Rob, it was really a pleasure to have you here. Tell us, what would you be comfortable talking about the next time?
Ooh, I've got a lot of talks. And next time we could dig into more details around Kubernetes or more details around testing. I have a really cool talk called Cypress Tests. I've forgotten the title of it, but it's working around Cypress testing, where we get to do end-to-end tests in a really automated way. That's usually that last mile where it's like, does my application work? Let's fire up Cypress and go run it through. I also have a great talk around Vue and TypeScript. Vue and TypeScript working together like peanut butter and jelly. They can be really fun. I did that in the Middle East, and so there it was.
So I just can recommend people to go to the WeAreDevelopers platform and look it up. So that was really amazing as well. And what I also would basically recommend everyone is to follow Rob on Twitter, because he's an amazing speaker with a lot of knowledge, and also check out his website.
That sounds perfect.
With that said, I hope you will get some better weather in Arizona over there. And looking at the time, we are actually going in a small break again for our last session. And so grab a coffee or a tea or whatever you would like to drink at this time, and see you again in 15 minutes.
That sounds great. Thanks, everyone.
Bye-bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
So, welcome back everyone to our very last session of the DevOps Day. I'm here with Danius from Vinted. So, Danius, hello, welcome.
Hi everyone.
How are you doing?
I'm doing really well.
Okay, Vinted is a very cool company, very trending here in Germany and Austria as well, basically. There have been some exciting news. So how is the day-to-day work for you today?
Oh, today is a very nice day. First, we started with some good news that we managed successfully have another funding round, and the weather is sunny out there, so perfect day.
Okay, 250 million, right?
Yeah, 250 million euros.
Wow. So with that, you can build some great, cool stuff, right?
We will continue doing this one thing, like making the second hand the first choice worldwide.
Yeah. It's an amazing product. So we have so many people here also saying, hey, cool that we have the guys from Kleiderkreisel, it was called here, or Vinted, joining us at our events. So yeah, very, very happy to have you here. Maybe you want to give us a brief introduction in what your talk is about and what people can take from that.
So today my talk is going to be about one particular bug that we hunted down, and I believe that I will convince you that you shouldn't change your Kafka topic partition count.
Okay. So then I would say the stage is yours.
Okay, thank you. Once again. Today I'm going to talk about one lesson that I've learned working at Vinted, and this lesson sounds like, don't change the partition count for Kafka topics. And I want to say thanks for Vinted for giving me the opportunity to work on cool things, and I want to thank WeAreDevelopers organization for providing me the stage today to talk about the things that I really like to do. Yeah, so first slide, who am I? My name is Danius Yotsas. I'm a software engineer working at Vinted. And the mission of the company is to make the second hand the first choice worldwide. My position at the company is called a staff engineer. By saying staff engineer means I'm working basically how to make the engineer's life easier. On the internet, you can find me on my website. I also post stuff on Twitter, and of course, I do have a GitHub profile. And I'm the author of a cool open source project, which is called the Scene Grep. Google for that one. Yeah, so let's go into the talk. So the talk is divided into 5 parts. First one is the introduction into the problem. The second one is the setup. I'll talk about the big picture, what's important there. Then we'll go into talking about the Heisenberg that we had, and then I'll talk about the fix of it. And at the end of the presentation, I will have some time for discussion and questions. So let's jump into the intro. The intro is pretty much the same thing that you read on the website. I'll just reiterate that in this talk, I'll tell a story about the Heisenberg and how we fixed it. And the actors of the story are Kafka Connect, optimistic concurrency control, data inconsistencies, and as site reliability engineers. And in some series of unfortunate circumstances, they collectively caused a nasty bug. So let's go into the setup. For this talk, I'll talk only about the relevant parts of the system that is there. But if you are curious for the detailed description of this whole setup, you can go to the Vinted Engineering blog and read all the details about it. Yeah, so the big picture of a system, the purpose of the system that I'm going to talk about today is to move the data from the primary data store, which is MySQL in Vinted's case, into the search server, which is Elasticsearch, that serves the search traffic of Vinted website. And to do that, we have a data indexing pipeline, which consists of some asynchronous jobs that takes data from MySQL, periodically checks data at MySQL, and if there is anything new, pushes that data into some Kafka topics. And then we have deployed the Kafka Connect cluster that whose job is to take the data from Kafka topics and push them into Elasticsearch. Okay, let's talk about those components from the previous slide in a bit more detail, but only just the relevant bits for this presentation. And as for Elasticsearch, the relevant bit is so-called optimistic concurrency control. So basically what this optimistic concurrency control means is that if the client that sends a data indexing request into Elasticsearch adds the version number of a document, then Elasticsearch promises that this, however many the indexing requests are coming in parallel, the resulting state in the index is that the document with the highest version number is going to be searchable. So, and let's go for an example in Vinted's case. Let's say that a user changed the price of her listing in the Vinted. Let's say the user decided that her shoes now are worth a bit more, so she changed the price. And so this change was propagated into Kafka with a new version number, and then this document was pushed into Elasticsearch so that when users are searching for shoes, the shoes with an updated price are retrieved. So the gist of the slide is that Elasticsearch stores only the newest version of a document. So that's all the things that you need to know about Elasticsearch for this presentation. Yeah, so let's talk about Kafka setup for a little bit. The interesting bit is that for Kafka, we do not delete data when it gets old. so what do I mean by not deleting? Is that we set the retention period to -1, which means that once the document is in the Kafka topic, that's it, it's there. Nobody is going to, the Kafka in the background is not going to delete it as it does by default. So this is needed to support this, as we call it, data reindexing task, which means that we can index the same data multiple times into probably multiple Elasticsearch clusters for production use, for test cases, etc. So you might have a question that how we are not running out of disk space in Kafka cluster. To overcome that issue, we do set law compaction. By law compaction, setting up the law compaction, Kafka promises us that it will always retain the last known value of each message key. And by doing this, it assures that we are not going to run out of this space, most likely. So another thing which is of interest for this talk is a thing called tombstone messages. And tombstone messages in Kafka means only that the message contains only a key and the body of a message is null. And these types of messages are used for deleting documents from Elasticsearch. And then, of course, all the usual Kafka properties, which are that Kafka promises that the newer messages will have a higher offset in Kafka topic partition, meaning that it has the total ordering of events within a partition. Okay, so let's talk about Kafka Connect. Kafka Connect is a framework and a library whose job is to move data either from some data store into Kafka or move the data from Kafka to some data store. In Vintage's case, what it does, it moves data from Kafka topics into Elasticsearch. Basically, in other words, it indices listings into Elasticsearch. And Kafka Connect provides us with built-in error handling, things like dead letter queues. It's very configurable. It's manageable. You can configure things like indexing throughput, meaning how many documents per time interval you want to index, and also, which is very important, concurrency, meaning how many indexing requests in parallel you can have. That was all about the setup. So the most complicated part and the most boring part is done. So the gist of the setup is that we use Kafka partition offset as an Elasticsearch document version number. And this trick allows us to parallelize indexing into Elasticsearch and or maybe I should say, knowing that we had a bug for it, should be worry-free from the data consistency point of view, meaning that whatever we put into Kafka, the same thing is in Elasticsearch consistently, with error-free. Yes, the setup is done. So life is good. But then one day, a colleague of mine wrote a Slack message which basically says that Elasticsearch fails to delete documents, which means that Elasticsearch is serving stale data. So I was impressed by this, and first I could not believe, because it shouldn't. The setup that, as I described previously, should prevent those things by design. So what I did, I just opened up my development machine and run the project on my laptop. So of course, Docker Compose cluster that has all the components. I ran some integration tests. Once again, looked through the logic there, and everything works as expected. Okay, fine. Then I decided to go to our shared testing environment that has even more components deployed there, but the highlights there are the single node Kafka cluster, the single node Kafka Connect cluster, and then the single node Elasticsearch cluster. I sent a couple of messages, clicked here and there, and everything worked as expected. So then I was pretty certain that, oh, it must be some glitch that happened somewhere. So what I've done, I've tried to send a tombstone message. Remember that the tombstone message is to delete documents from Elasticsearch. You send a record with a null body to Kafka, and then Kafka Connect deletes documents from Elasticsearch. And then, shockingly, after a couple of minutes of waiting, the document was still present in Elasticsearch. And about it, I felt really bad. You know, that bad, that is comparable to a situation where a good friend just betrayed you in some very bad way. Like, how come that this can happen? Yeah. So then I thought for a bit, and yeah. So okay, once again, a document in Elasticsearch index should have the same version attribute that is equal to the offset attribute of the message in the Kafka topic partition. So this is the theory that is behind this worry-free guarantee. Okay, let's go into details and check manually what happens in the system. So what I've done the simple curl into our production cluster just to check what's the version number of a problematic document that was reported by my colleague, and the version number is some big number. This is all you need to know in yellow. So okay, I've recorded the version number as it is recorded in Elasticsearch. Okay, fine. Then on the other side, I've tried to send. We have a tool called AM, which stands for Elasticsearch Index Management, and strangely enough, it knows how to delete records from a topic in Kafka. But this is the way how it works at Vinted. So I've sent a delete records message with the key, which is an ID from the previous slide, and the output of this command is as follows. It says that it sent a record to Kafka topic, which is core items, into partition number 17 with an offset of some big number. Sorry. Okay. So now I have those two pieces: the document version number in Elasticsearch and a document and the record offset in Kafka topic. So okay, I have those two things. Now I have to think a bit. Is there anything wrong about those two numbers? And from this point of view, nothing seems to be very wrong. It's like one number and then another number. But to see what's wrong with them, we have to change a perspective a little bit. So let's put those numbers in this way. And then we have this eureka moment that one number is a lot bigger than another one. It's like 10 times bigger, so it has more digits. And remember, this one is the document number, document version in Elasticsearch index, and this one is the offset in Kafka topic. And seeing those two numbers, I got two really big questions. How come that the newer message has a lower offset? Or to put it in other words, how come that the older record, which stands for the version in Elasticsearch index, remember that there should have been one record in Kafka with that offset that resulted in the version number in Elasticsearch. Then how come that the older record, that one, has the higher offset than this one? So how come this can happen? And I believe that this is the root cause of the problem. So what happened then, I turned into some literature. Namely, I opened up the book, the Kafka, the Definitive Guide, which, by the way, I highly recommend for everyone who has to do anything with Kafka. Read that book and your life will be much easier other than not reading it. So I checked how this can happen there. And after consulting the literature, I've learned that the only situation how this could happen is that somebody changed the number of Kafka topic partitions. And to check that, I opened the Grafana dashboard and noticed that a couple of months ago, the partition count was increased from 6 to 24. And that was the root cause of a problem that we faced. And because of that, the newer records in Kafka were seen as all the records from Elasticsearch point of view. So, okay. So what's the problem here? What's the root cause? Like, how can I explain it to somebody? And to explain it properly, we need to run once again about what guarantees Kafka gives us. So Kafka tells us that it guarantees the ordering of messages for a key in a partition, but at the same time, it does not guarantee us any ordering across partitions for the same key. Then, okay, how can this happen that we started to talk about one key across the partitions? So how Kafka decides to which partition a particular message goes? So Kafka assigns partitions to messages by hashing the key of the message, as you can see in this little code snippet in the slide. But then what happened when another developer changed the topic partition count? It changed the second part of this little function there, which means that the messages started to be recorded at different topic partitions, which is a problem. And the problem was and the problem appeared most of the time when records were updated, and I did a little calculation on that calculated the probability of an error, and the probability was 1 minus 1 over partition count, and partition count in this case now is 24, so it's more than 95% of cases of document updates were badly recorded. Yeah. So now we know what happened. Now we understand why this happened, why the error was present, but then we don't know the motivation of let's say a bad actor, which was the SRE that changed the Kafka topic partition count. And the last question from the situation is that why would somebody increase the partition count for Kafka topics? So we have to go back to Kafka design, and the partition in Kafka is a scalability unit, meaning that if you have more partitions, your write scales up, so you have more write throughput. So, and the limitation for one partition is that it should fit into a one Kafka node. And the more partitions you have read scalability. So the Kafka, remember that consumers for Kafka consumes at least one partition. So the more partitions, the more consumers, the more parallelism, and yeah. So partition is a scalability unit in Kafka. So the answer to the question of the slide is that the SRE wanted to make sure that that a single partition fits in one node, and he wanted to increase the throughput of Kafka, of our Kafka deployment. So yeah, now we know that there was a problem. What caused the problem? what was the technical reason for the problem and why somebody introduced that problem without knowing what he was doing. Okay, so then we can move into how to fix such a nasty bug, because we had, remember that that there were a couple of months ago that the bug was sitting in the system for a couple of months until some developers or some users even noticed that their listings were not properly handled by Vinted. So the proper solution or a proper fix for the problem requires a full data reingestion from the primary data store into Kafka. So meaning that we had to run the job that reads through all the MySQL tables from beginning till the end and pushes that data once again into a new Kafka topics, just to have this ordering right. So yes, it would be enough just to write data into differently named topics. But since we were a bit more ambitious and we had a pending cluster upgrade, we decided to go a bit off-road and to start up another Kafka cluster with a newer version and just do the data reingestion into that new Kafka cluster. And from the new one, restore the data into Elasticsearch. And I have to say that everything went smooth as a Rolls-Royce, as a ride with the Rolls-Royce. Yeah. So so the story ends there. So now we can go in a bit into the lessons learned session and so how to prevent such a bug in your system. So the gist of the presentation is that don't increase partition count if you rely on message ordering. If you don't rely on message orderings and you usually don't rely on message orderings in such Kafka deployments for the logging, some metrics or some event tracking, those high volume stuff that just you can even drop some values. But for use cases where you use some Kafka bits that are not if you use Kafka for things that you cannot lose data, don't increase partition count. That's my advice for you. So what to do then? You should set the sensible default for Kafka settings, like we talked before about the partition count. So make the partition count as high as you need, and don't change it afterwards. And yeah, so if you don't rely on offset, you can do whatever you please with your partition count to satisfy the throughput needs, or otherwise don't increase the partition count. Yeah, and yeah, so that's pretty much it what I had for you today. And if you have any questions, I would be happy to answer them.
Hey Denis, thank you very much for your presentation. I hope people have enjoyed it. I did enjoy. We have one question, but actually you have already answered it in the last part. So Mark is writing very structured explanation and also fun. Wondering if you have advice on how to prevent such corner cases happening. You touched that question already.
I touched it. Yes, I touched it. I've touched it a bit. And
maybe you want to go deeper.
Yes, I could elaborate a bit more on how, not on how, on why it is hard to prevent such bugs. Like internally, when we discussed this issue with other guys, we also thought about how to prevent such things in the future. And one question that popped up was, could we set up monitoring for such such bugs. And we thought about it for a while, and the outcome was that it's not really preventable by monitoring, because that would mean that the system is eventually consistent. So at one point in time you send a message into Kafka. At some point in time later, let's say after 5 minutes, you have some state, this document, this record propagated into Elasticsearch. So you have 5 minutes to wait until this let's say original event propagates to the end system. And to have a monitoring would mean that that it should go through the Elasticsearch, like most likely periodically, and then check what's the version in MySQL database. But to support such use case, you should have some logic sitting there. Like you should implement some sort of time traveling queries. Like, is this version in Elasticsearch consistent with the version at MySQL, or if you discover that MySQL has a newer version of the document that is not in Elasticsearch yet. So what do? You check the timestamp, meaning that is it had the change happened in more recently than in last 5 minutes? Remember the delay between the when event is written to Kafka and that is propagated into Elasticsearch, or some other machinery that just tries to match the state in Elasticsearch and MySQL. And sometime, and what was the outcome at the end? That by monitoring, it's not really preventable. And because the resources required for such monitoring would be at least as big as the system itself.
So it would be kind of over-engineered. So would you say this Heisenberg that you encountered here is something that basically is not worth preventing?
It's not, no. I would say it in a bit other way. So it's not worth preventing, but it's prevented by design of the system. So the way that Kafka Connect, and Elasticsearch works, you can set it up to work like this. This bug should not happen at all. It just doesn't happen. However, once you change some fundamental aspect of a system, then you have this Heisenberg. So,
okay. Yeah, that's kind of a really an edge case.
Yeah, this is an edge case, and
we experience it once in a lifetime.
Yeah, that's why I wanted to share my story with you guys.
That's interesting. Is it the first time that you had something like that?
I would say that this one is the juiciest one, but similar errors were all over the place throughout my career, since I'm working mostly with search systems, which are mostly the downstream databases, and I always rely on some eventual consistency happening. So these types of bugs are not very rare, let's say.
Yeah. Okay. I have also a bug here. So this light is flickering, so I'm turning the light around. So kind of annoying. Sorry. Okay. Let's see if there is another question. There is. How big is your engineering team, and what are you hiring for, and where?
Oh, very good question. Thanks.
That's the slot where you now can basically do the promotion.
Yes. So our engineering team is I don't know the exact number, but it's somewhere close to 200 engineers strong. And we are engineering mostly for everything. Not engineering, hiring. Mostly for all the engineers we can get, and we primarily hire engineers in two places, or at least we expect them to be in the same let's say time zone. So meaning that our primary destination is Vilnius, Lithuania, and then there is a second developer hub being opened is in Berlin. So if you want to work on problems that Vinted is having, you're mostly welcome to talk with us.
Okay, and it's not always a Heisenberg, so don't be scared to apply. That's nice to hear. Are these people going to work also remote? Because you say it's like in the same time zone, or?
So, yeah, the policy as of now is that that we can hire people that are working remote, but the main hiring is happening for let's say for people that are working on the similar schedule as everybody else.
Okay.
So remote is possible, definitely.
Okay. Denius, this was, I think, a very nice story for the last session of the DevOps Day. So thank you so much for joining us. I hope to see you also at some point in the future at an in-person event. And I can only wish you a nice evening. I think it's now around 7 p.m. in your time zone, right?
Yes, around 7.
Yeah. Okay, then have a nice evening and see you soon. Bye.
Yeah, thank you all for having me. It was a pleasure, and have a nice evening all. Bye.
Bye. Okay, that was the last session of the DevOps Day. It was a blast. I can only say thanks to everyone for joining us. If you joined us later, no problem. You can rewatch the recording at any time. I know a lot of people are watching us also in the evening. So yeah, have fun with the talks that we had today. Before we close the stream, I just want to remind you again that we have the WeAreDevelopers World Congress happening at the end of June with very cool speakers, Tim Berners-Lee, Jeff Atwood, Mishko Hevery, a lot of other great people and tech pioneers are joining this Congress. It takes place online, so you can basically lean back and watch it from all over the world. Make sure to grab your early bird ticket. Secondly, if you are looking for a job, if you're looking for a DevOps job or for some other roles, then please visit WeAreDevelopers.com. You will find a lot of jobs in Europe. Scan the market. Most of the jobs have upfront salary information as well. You can see the benefits of the companies and of the jobs. So maybe there is something also for you. And last but not least, I want to say a huge thank you to Vienna Up. Vienna Up is a startup event that happened in Vienna. It's one of the largest congresses or events taking place for startups in Europe. Today was the last day, and thanks also to everyone who joined us from this side. With that said, I wish you all a very nice evening and see you soon again. Bye bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.